there is a place at the center of our galaxy where the known laws of nature break. A point so dense that time itself folds in submission, where gravity becomes geometry and light surrenders to silence. We call it Sagittarius A star, a black hole 4 million times the mass of our Sun, spinning quietly at the heart of the Milky Way. Around it, stars move at unimaginable speeds, tracing orbits that reveal the invisible. It is both a grave and a beginning, a paradox written in starlight, and though no human can ever touch it, we are all bound to its pull. What happens at the heart of everything? What lies beyond the event horizon, the point of no return? Like and subscribe to join this voyage through the cosmic unknown. Close your eyes, breathe deeply, and drift with us to the center of the galaxy. Let's begin. At the heart of the Milky Way lies a presence so immense that space itself bends in silence. Sagittarius A star, a black hole 4 million times the mass of our Sun, rests in darkness, invisible yet undeniable, the still point around which our galaxy turns. From our position on the outer spiral arm, we orbit this unseen giant like a distant thought circling a memory. 26,000 light-years away, it waits in the constellation Sagittarius, hidden behind clouds of gas and dust so thick that visible light cannot pass through. Yet, even unseen, its pull shapes everything. Every star, every planet, every wandering comet in the Milky Way moves in quiet obedience to its gravity. Astronomers discovered its presence not by what they could see, but by what they couldn't. In the 1990s, teams at the Keck Observatory and the European Southern Observatory began tracking a cluster of stars near the galactic center, tiny points of light whipping through space at thousands of kilometers per second. Their orbits traced an invisible mass, compact and unimaginably heavy. The only thing dense enough to explain their motion was a supermassive black hole. Sagittarius A star was no longer just a theory, it was a fact. Even now, our most advanced telescopes cannot pierce its heart. What we see instead is the chaos around it, the glow of matter drawn too close, spiraling inward like a whirlpool made of fire. As gas falls toward the center, it heats to millions of degrees, emitting X-rays that flicker like distant lightning. Each flash is the final heartbeat of something that once was. A fragment of a star, a wisp of hydrogen, a story ending in light. And yet, there is stillness at the core. Beyond a certain point, the event horizon, gravity becomes so absolute that even light cannot escape. Inside, all paths lead inward. Time itself loses meaning. To an outside observer, anything crossing that boundary seems to freeze in place, stretched thin by the warping of space-time. But from within, the fall continues forever, smooth, inevitable, eternal. Sagittarius A star is both sculptor and destroyer. It devours matter, but in doing so, it gives the galaxy its form. Its gravity keeps the Milky Way bound together, maintaining the delicate balance that allows stars like our Sun to exist where they do. Without this dark anchor, the spiral arms would drift apart over billions of years, dissolving into cosmic dust. The galaxy owes its shape to something that cannot be seen. There is a strange comfort in that thought, that invisibility can still hold meaning, that silence can shape everything. Sagittarius A star is a reminder that the universe doesn't need to shout to be powerful. It moves quietly, patiently, letting gravity write its story in the motion of stars. And as we drift through space, orbiting that same invisible center, we too are part of its rhythm. Every second, every breath is tied, imperceptibly but undeniably, to the dark heart that pulls all things home. Nothing that enters its grasp can ever return. Not light, not time, not memory. The event horizon is both a boundary and a promise, a one-way gate into the unknown. This is the line the universe itself draws, the point where gravity grows stronger than the speed of light. Once something crosses it, whether a beam of radiation a drifting asteroid, or an entire star, it is gone forever, sealed inside the black hole's shadow. There is no reflection, no echo, no way back. What remains is silence, and the faintest shimmer of energy as space bends under the weight of what it has lost. To understand how such a boundary forms, we must imagine what happens when gravity wins. When a massive star exhausts its nuclear fuel, it collapses inward under its own weight. The atoms that once pushed outward in fusion surrender, crushed into oblivion by their own mass. If the star is large enough, even the laws of physics can no longer resist. Matter condenses past any imaginable limit until all its mass is concentrated into a single point of infinite density, a singularity. Around it, space-time curves so steeply that every possible path leads inward. This curvature defines the event horizon, the invisible sphere where escape becomes impossible. If you hovered just outside that boundary, time itself would begin to stretch. Seconds near the horizon would pass like centuries to an observer far away. To you, the universe beyond would seem to speed up, stars aging, galaxies spinning, the cosmos racing toward its own distant future. But to the outside world, you would appear frozen at the edge, suspended forever in the act of falling. Both perspectives are true, both are incomplete. Even though light cannot escape, the event horizon is not pure darkness. Matter approaching the boundary emits brilliant radiation as it accelerates to near light speed, colliding and compressing in the final moments before disappearance. This glow is what we see in images of black holes, the halo of doomed light tracing the edge of forever. It is not the black hole itself that shines, but the story of everything it consumes. Einstein's equations predicted this strange threshold long before we ever imagined seeing one. And yet, when humanity finally captured an image of a black hole in 2019, it looked exactly as the math foretold: a ring of fire surrounding a shadow that light could never cross. It was both haunting and beautiful, the first visual proof that the universe keeps its promises. But perhaps the event horizon is not just an end. Some physicists believe information about what falls inside might still linger, encoded in faint radiation or ripples in space-time. If true, then even the darkest places in the cosmos are not prisons, but vaults, holding the patterns of everything they've taken. The light that never escapes may not be lost forever. It may simply be transformed, waiting in a form we cannot yet understand. In that way, the event horizon becomes less of a wall and more of a mirror, showing us that even endings in the universe are only another way of continuing. We cannot see it directly, but we can trace its shape through motion. Stars at the galactic core whirl around an unseen center, their orbits sketching a shadow that gives the invisible form. For centuries, the idea of something so massive, yet unseen, was unthinkable. The night sky seemed timeless and still, a place where stars shimmered in gentle permanence. But deep near the constellation Sagittarius, astronomers began to notice something unusual: a cluster of stars moving far faster than any others in the galaxy. Their paths weren't random or chaotic. They curved and looped as though tethered by an invisible thread, orbiting an emptiness that radiated no light. In the late 20th century, long before we ever imaged a black hole, two teams set out to watch this cosmic dance unfold. Using powerful telescopes at Mauna Kea and the Very Large Telescope in Chile, they tracked the motions of individual stars year after year. One of them, a bright blue star named S2, raced around the unseen center once every 16 years, its speed peaking at nearly 8,000 kilometers per second. The only explanation for such movement was staggering: something 4 million times more massive than the Sun, confined within a space smaller than Mercury's orbit. That something was Sagittarius A star. We could not see it, but through the precision of these orbits, we could map its existence, as surely as one might deduce the shape of the wind by watching trees sway. Each star became a compass needle, aligning itself with gravity so powerful it bent time as easily as it bent light. The result was a map, not drawn in ink, but in motion. Even now, when astronomers simulate these orbits, the stars appear to dance, tight ellipses flashing around an emptiness that pulls them home. Their motions tell us more than any image could. They confirm Einstein's general relativity, showing that space near Sagittarius A star is curved exactly as his equations predicted. The stars don't simply orbit through space, they orbit through time itself, following paths dictated by the geometry of gravity. We call this mapping the invisible, but it's also a kind of listening. Each orbit, each gravitational tug, is a note in a silent song, one that reveals structure through rhythm rather than sound. As we record it, we begin to understand that what is unseen isn't unknowable. The universe whispers through the behavior of what it touches. Today, advanced observatories like the gravity instrument at the Very Large Telescope Interferometer can detect minute shifts in these orbits with stunning precision. By studying those shifts, scientists can measure not just the mass of Sagittarius A star, but the spin of the black hole itself, how fast it twists space-time around its event horizon. Through the movement of distant suns, we have drawn the outline of a shadow. We have mapped the borders of a thing that should not be visible, yet defines everything around it. The stars, faithful and patient, continue to orbit. And in their paths, we find not darkness, but understanding. Proof that even the invisible leaves a trace. Every 11 minutes, Sagittarius A star pulses faintly in radio light. Astronomers call it flickering, but it feels more like breathing, the slow rhythm of something alive beneath layers of space-time. Each pulse is a whisper from the edge of the abyss, a soft rise and fall in brightness that echoes across 26,000 light-years. To the instruments that capture it, it appears as a rhythmic shimmer in the radio spectrum. To the human mind, it feels like a heartbeat, a reminder that even the darkest regions of the cosmos are not still, but alive with motion and energy. These fluctuations puzzled astronomers for years. At first, they seemed random, erratic bursts from a turbulent region near the event horizon. But as data from the Chandra X-ray Observatory and the Atacama Large Millimeter Array accumulated, a pattern began to emerge. The flickers weren't chaos. They were a pulse, repeating every few minutes, each one marking the orbit of matter spinning dangerously close to the black hole's edge. Imagine plasma clouds, each one the size of a planet, whirling around Sagittarius A star at nearly the speed of light. Magnetic fields twist them into luminous knots, heating them to millions of degrees. As they circle, they beam energy outward. Brief flashes of radio and infrared light that rise and fade like sparks in the dark. These are the breaths of the galaxy's heart, visible only to telescopes tuned to listen in frequencies beyond human sight. To us, the rhythm feels slow, serene even. But near the event horizon, time flows differently. Those 11 minutes could be hours, days, or years to the matter spiraling within. Relativity stretches time until it becomes elastic, softening each beat into something eternal. What we perceive as a pulse may be, for the matter falling inward, its final instant of existence. Some scientists suggest these flickers may reveal the spin of the black hole itself. As gas and dust orbit within the warped fabric of space-time, they trace the contours of the hole's rotation, allowing us to glimpse not just its hunger but its motion. The flicker, then, becomes a form of communication, a gravitational Morse code written in radiation. When viewed through the Event Horizon Telescope's global network, these pulses create ripples across data maps, forming patterns that help refine our models of Sagittarius A star. Each variation, each subtle change in brightness, adds a stroke to the portrait of the unseen. We are, in a sense, listening to the Milky Way's heartbeat, its tempo measured not in seconds, but in space-time. And yet, there's something deeply human in that rhythm. For billions of years, the galaxy has turned around this dark center, its stars moving to a pulse we only recently learned to hear. Every 11 minutes, a breath. Every 11 minutes, a reminder that even in the most silent reaches of the universe, there is motion, warmth, and continuity. Perhaps it's not too far-fetched to think of it as life. Not in the way we define it, but in the way the cosmos expresses persistence. The galaxy breathes, slowly and steadily, its heartbeat echoing through radio waves that have traveled across time to reach us. And in that faint, steady pulse, we find proof that even darkness has rhythm. Stars, bright and reckless, move in elliptical paths so tight they complete full orbits within decades. Their motion is proof of gravity in its purest form. Curved light, curved time, curved destiny. These stars are the closest companions to Sagittarius A star, circling it in a gravitational ballet unlike anything else in the galaxy. Each one follows a unique trajectory, weaving through invisible tides of space-time that twist their paths into elegant, perilous loops. To an observer, they appear to dance, bright points of light darting through darkness, their orbits overlapping in a choreography choreographed by gravity itself. At the heart of this stellar cluster is S2, the most famous of them all. Roughly 15 times more massive than our Sun, S2 races around Sagittarius A star at a breathtaking 8,000 kilometers per second, nearly 3% the speed of light. Its orbit brings it as close as 120 astronomical units to the black hole, about 3 times the distance from the Sun to Pluto. At that proximity, the black hole's immense pull stretches space like an elastic sheet, bending S2's light as it swings around in a tight, brilliant arc. For over 2 decades, astronomers at the Keck Observatory in Hawaii and the Very Large Telescope in Chile have watched S2 trace its looping path. Each return confirms what Einstein's general relativity predicted: that gravity is not a force pulling through space, but space itself curving around mass. As S2 passes near the black hole, its light shifts to longer wavelengths, a gravitational redshift, proof that time itself is slowing in the presence of immense gravity. The stars serve as test particles in a natural experiment on the grandest scale. Through them, we measure the black hole's influence, its spin, and even the subtle warping of the fabric of space-time around it. Their movements are recorded with astonishing precision, measured down to micro-arc seconds, the equivalent of watching a coin spin on the moon from Earth. Each data point refines our map of the invisible, each orbit another line in the signature of Sagittarius A star. But beyond their scientific value, the stars are a spectacle of cosmic resilience. How do such fragile objects survive in a region of such chaos? Their very existence hints at hidden histories. Perhaps they were flung inward by interactions with other stars, or formed from compressed gas clouds that somehow resisted the black hole's destructive pull. Whatever their origin, they endure, glowing defiantly in a place where nothing should. When their light reaches us, it has traveled for 26,000 years, carrying with it the trace of each gravitational curve, each distortion, each whisper of the black hole's pull. In their movement, we glimpse time as a living thing, stretching and folding as it obeys the invisible rhythm of gravity. They are the dancers at the galaxy's core, swift, brilliant, fearless. Their stage is space-time itself, and their audience is every being who has ever looked up and wondered what holds the stars in place. Around darkness they spin, bound not by light, but by inevitability. And as they complete their endless orbits, they remind us that even in the deepest gravity wells, beauty persists, and motion, not stillness, defines the heart of the universe. Near Sagittarius A star, gravity stops being a force and becomes geometry. Space folds inward, time stretches thin, and every rule that defines the universe begins to blur. Here, the comforting concepts we use to describe reality, distance, direction, duration, start to lose their meaning. What we call gravity is no longer a pull in the traditional sense. It's a warping of the very stage on which all events unfold. Matter doesn't fall towards Sagittarius A star because it is drawn in. It moves along the natural curves of space-time itself, descending through a valley so deep that even light cannot climb back out. Imagine standing at the edge of that well. If you could see space-time as a fabric, it would look like an endless funnel, narrowing toward a point of infinite depth. Objects near the rim move swiftly, circling like leaves caught in a whirlpool, while those closer to the center stretch and twist into ribbons of energy. This is not a metaphor, it's physics. The curvature of space determines the motion of matter, and the energy of matter determines the curvature of space. The two are inseparable, locked in an endless conversation written into the laws of general relativity. The deeper you fall, the stranger things become. Clocks tick slower the closer they are to the black hole's center. To a distant observer, your fall would seem to slow, then freeze at the event horizon, an image of you suspended forever at the edge of darkness. But from your own perspective, you would continue descending without pause, the universe behind you accelerating toward eternity. This distortion of time isn't unique to black holes. It happens around all massive objects, even Earth. But near Sagittarius A star, the effect becomes extreme. Time here is stretched so far that seconds can become hours, and hours can become centuries, depending on your position in the gravitational field. It's as if each layer of space-time moves to a different tempo in an invisible symphony, one where gravity conducts both matter and time. Astronomers studying the region have found that this warping has measurable effects. Light emitted from gas near the event horizon is redshifted, its wavelength stretched as it struggles to climb out of the gravitational pit. The glow we see from Sagittarius A star isn't simply bright, it's distorted, a message encoded in the language of warped space-time. And yet, this distortion is what allows galaxies to exist. Gravity, in its gentlest form, pulls planets into orbit and shapes stars from gas and dust. In its most extreme, it folds space into wells so deep they sculpt the universe itself. Without gravity's geometry, the cosmos would have no structure, only endless expansion and silence. So when we look towards Sagittarius A star, we are not witnessing chaos, but the architecture of existence. The black hole's gravity well is the blueprint from which the galaxy is drawn, a silent engine that sculpts everything it touches. And in that invisible architecture lies a truth as profound as it is humbling. The universe isn't built from solid matter, but from curves in something deeper, something that binds light, time, and destiny into a single, continuous shape. Sometimes, gas clouds drift too close. They spiral inward, heating to millions of degrees before vanishing. Each flare we observe is a final scream before silence. The space around Sagittarius A star is not empty. It is filled with drifting clouds of hydrogen, dust, and fragments of once whole stars. Most pass by harmlessly, tugged but not claimed. But every so often, a fragment crosses an invisible line and begins the long descent inward. From that moment, its fate is sealed. Gravity takes hold, and what was once a slow drift becomes an unstoppable fall. As the gas spirals toward the black hole, it compresses and twists into glowing ribbons, colliding with itself as it accelerates. Friction and magnetism transform that fall into light, radiation so intense it briefly outshines entire galaxies. The matter, once cold and quiet, burns with a final brilliance, releasing all its energy in one last flare before crossing the event horizon. What we see from Earth are these dying flashes, short, powerful bursts in infrared and X-ray wavelengths that last minutes or hours but took tens of thousands of years to reach us. Astronomers first observed such flares in the early 2000s using the Chandra X-ray Observatory. They appeared suddenly, then vanished just as fast, as though Sagittarius A star had taken a single breath. Later observations from the Very Large Telescope and the Atacama Large Millimeter Array confirmed that these flares were the signatures of matter on its final approach. Tiny, doomed worlds of plasma plunging into the dark. Each flare told a story of something being undone, of energy transformed and order erased. It's a violent process, but not without beauty. The gas clouds trace elegant spirals as they fall, glowing with colors our eyes can't see. Deep infrared, soft X-ray, the ultraviolet shimmer of annihilation. For a brief moment, they become lanterns in the galactic night, illuminating the very edge of what physics allows. And then they are gone. No debris, no sound, only the faint gravitational ripple left behind. The energy released in these moments is staggering. A single flare can emit more power than 1,000,000 suns combined. Yet, in the vast scale of the galaxy, it is a whisper, a brief flicker of light swallowed almost immediately by the black hole's gravity. What remains is an echo, a ripple of information carried across the electromagnetic spectrum, allowing us to reconstruct the story of its fall long after it has disappeared. These events remind us that creation and destruction in the universe are not separate. They are the same act seen from different sides of time. The gas that falls into Sagittarius A star once drifted among stars, and the energy it releases now travels outward, perhaps someday helping new stars form. In that way, even the final scream of infalling matter becomes part of the galactic cycle, a transfer of light from one era to the next. When we detect these echoes, we are listening to the galaxy, remember. Each flare is not just an end, but a conversation between gravity and energy, chaos and order, a reminder that even as matter vanishes into darkness, it leaves behind a trace, a faint, luminous echo of everything it once was. Around the black hole swirls a disk of superheated plasma, spinning near light speed. It glows in X-rays, painting the darkness in light born from destruction. This is the accretion disk, a cosmic furnace where gravity and motion blur into fire. Gas, dust, and fragments of stars drawn too close to Sagittarius A star flatten into a glowing ring, spiraling inward in an endless storm of friction and fury. Here, matter doesn't simply fall, it's shredded, compressed, and heated to tens of millions of degrees. The result is a halo of radiation so bright that, for a fleeting moment, it outshines the combined starlight of the entire galaxy's core. In the disk's chaotic embrace, atoms are torn apart, their electrons ripped free as magnetic fields twist and snap like whips of energy. This turbulence, though invisible to our eyes, sculpts the disk into layers, cooler material in the outer regions, hotter and more violent as it nears the event horizon. Every flicker of light from this maelstrom is a message from the edge of eternity, a signal shaped by relativity and raw thermodynamics. If you could stand safely nearby, though no material object could, the sight would be overwhelming. The disk would appear as a glowing whirlpool, one side brighter than the other due to the Doppler effect, where light from matter moving toward you is intensified while the opposite side fades into shadow. Space itself seems to twist, light bending around the black hole in impossible arcs. The result is not just a ring of fire, but a mirrored illusion, one disk appearing above and below, curved by gravity's lens. In 2022, the Event Horizon Telescope gave us humanity's first view of this phenomenon around Sagittarius A star. What we saw was not a perfect circle, but a shimmering halo surrounding a void, the shadow of the black hole itself. It was not an artist's rendering or a theory anymore. It was real light, captured from the most extreme environment we can imagine, a portrait of gravity consuming energy and turning it into beauty. The accretion disk is not stable forever. Over time, its material either plunges past the event horizon or is hurled outward by magnetic jets that shoot perpendicular to the disk at near light speed. These jets, invisible in optical light but blazing in radio and X-ray, can stretch for thousands of light years, injecting energy and matter back into the galaxy. From destruction comes renewal, the raw material for future stars, planets, and perhaps even life. And yet, what draws us most to this place is not its violence, but its paradox. The closer matter gets to oblivion, the brighter it becomes. It is as though the universe insists that before anything vanishes, it must first announce its passing in light. The accretion disk is the last threshold between being and nothingness, a luminous border that marks the divide between what can be seen and what can never be known. In its swirling heat and colorless radiance, it tells the oldest story in the cosmos, that every ending is radiant, and even the act of being consumed can illuminate the dark. To watch this region is to see Einstein's equations made real. Time dilation, frame dragging, gravitational lensing, all dance together in perfect, terrifying symmetry. Near Sagittarius A star, the universe no longer behaves like the familiar world we know. The geometry of space twists upon itself, and time stretches and folds in obedience to the immense curvature of gravity. Here, relativity stops being theory and becomes landscape. Every photon, every particle, every breath of energy must follow the geometry drawn by Einstein's equations more than a century ago. If you could drift above the black hole, what you would see defies intuition. Light bends into loops, tracing impossible paths as it circles the event horizon before escaping into the wider galaxy. A single photon might orbit the black hole multiple times, creating a luminous ring where light both arrives and departs simultaneously. Space itself becomes a mirror, reflecting the shape of gravity back into our eyes. This bending of light, gravitational lensing, allows us to see what should be invisible. The black hole's immense pull warps the path of photons from distant stars, smearing their images into arcs and halos. What seems like an abstract phenomenon in textbooks reveals itself here as a kind of cosmic art, space-time painting with light that has been bent, delayed, and reborn. But there's another effect at play: frame dragging. Because Sagittarius A star spins, it drags the very fabric of space-time along with it. Anything that ventures too close, even light itself, is pulled into this rotation. To an observer, space appears to swirl, as though caught in an invisible whirlpool. It's as if reality has a current, a flow determined by the spin of an object that warps both direction and destiny. And then there is time dilation, the most haunting of them all. The closer you move toward the event horizon, the slower time passes relative to the universe outside. A minute for you could mean years for someone far away. To an outside observer, you would seem to freeze at the edge forever, never quite crossing, trapped in a slow-motion eternity. But from your own perspective, your fall would continue smoothly, your last heartbeat occurring in silence beyond time. Astronomers have confirmed these effects through the orbits of stars near the galactic core. As they swing around Sagittarius A star, the light they emit shifts toward the red end of the spectrum, its wavelength stretched by gravity itself. This gravitational redshift is direct evidence of time dilation in action. Einstein's most abstract concept written in starlight. What makes this region so mesmerizing is its harmony. These effects, bending, twisting, slowing, don't occur separately but together, woven into a seamless performance where the universe itself is both dancer and stage. The physics that governs falling apples and orbiting planets is the same that curves light and reshapes time, only magnified to a scale so vast it feels like poetry written in equations. To study Sagittarius A star is to gaze into a living demonstration of relativity. Here, the universe shows us its true face, a reflection of order hidden inside apparent chaos. The closer we look, the more we realize the black hole isn't defying nature. It is nature, seen in its purest, most perfect form, a mirror held up to the structure of reality itself. In 2022, the Event Horizon Telescope captured its first image. A glowing ring surrounding a hollow center. It wasn't just a photograph, it was humanity's first glimpse into the abyss. For decades, Sagittarius A star was a theory, an idea wrapped in equations, its presence inferred from motion, from gravity, from silence. The black hole itself emits no light. It hides behind its own gravity. What shines is the matter around it, superheated gas in the accretion disk, bending and warping as it dances near the event horizon. To capture that light required a telescope the size of the Earth itself. And so, astronomers built one. The Event Horizon Telescope, or EHT, wasn't a single instrument, but a network of 8 radio observatories scattered across the planet, from Hawaii to Chile, from Spain to the South Pole. Together, they formed an Earth-sized eye capable of resolving details finer than any optical telescope in history. For 5 nights in April 2017, they turned their synchronized gaze toward the heart of the Milky Way, collecting petabytes of data in wavelengths invisible to human eyes. Those signals traveled to massive supercomputers, where they were combined, photon by photon, into a single coherent image. When the image was unveiled 5 years later, it stunned the world. Against the blackness of space, a blurred orange ring shimmered into view, surrounding a dark center. It wasn't perfect, it wasn't sharp, but it was real. That ring of fire was the final light from matter orbiting the event horizon, the point where light itself can no longer escape. The dark center, the shadow, wasn't the black hole itself, but its imprint, the silhouette cast by gravity on the glowing plasma behind it. Scientists and artists alike called it a photograph of the unseeable. Every pixel in that image carried the weight of relativity. Light distorted, delayed. The ring wasn't just glowing matter, it was space-time illuminated, an image drawn by the bending of reality. The moment carried a quiet, almost spiritual resonance. Something 4 million times more massive than our sun, 26,000 light-years away, rendered into a glowing halo of truth. It was both terrifying and tender, a portrait of gravity's perfection. Yet what the image truly represents is not an end, but a beginning. It proved that our understanding of the universe, our equations, our instruments, our collective curiosity, could reach beyond light itself. That even in the darkest places, knowledge can cast a glow. When we look at that shadow, we're not seeing something alien or distant. We're seeing the shape of inevitability, the form of gravity, the architecture of space-time, the echo of every law that allows us to exist. The shadow revealed is, in a way, a reflection of ourselves, humanity looking into the unknown and realizing that we, too, are part of the same beautiful darkness. Imagine descending toward that center. At first, the stars grow brighter, then they smear into streams of light. Space stretches, time slows. Your heartbeat becomes an echo across infinity. It begins quietly, a slow drift toward the galactic heart. The black hole is still distant, invisible against the starlit haze, but its pull is constant, steady, absolute. As you draw nearer, the familiar sky begins to warp. Stars that once shone as steady points of light begin to bend around an unseen center, their positions distorted by gravitational lensing. Ahead of you, Sagittarius A star waits, a silent eye of darkness surrounded by a glowing ring that never stops moving. The first sensation is weightlessness, not the gentle floating of space travel, but something deeper. The pull of gravity doesn't tug at your body, it reshapes the space your body occupies. Every motion feels slower, more deliberate, as though time itself has thickened. You are not falling through space. Space is falling with you. As you approach the accretion disk, the sight is overwhelming. Rivers of plasma flow like molten gold, spiraling at near light speed, each particle glowing with the energy of its destruction. The light bends around you, curling into rings that seem to form and dissolve at once. The black hole's rotation drags space-time into a whirlpool, and you begin to feel it, a subtle twisting, as though reality itself has started to spin. Crossing the outer edge of the accretion disk, radiation surges around you. If your eyes could withstand it, you'd see photons orbiting the black hole multiple times before escaping, creating a halo of repeating images. You might catch glimpses of your own reflection from 1,000 different paths of light, distorted, stretched, delayed, the universe showing you all the ways it perceives your fall. And then comes the horizon. The event horizon is not a wall, not a surface you can touch, but a boundary defined by inevitability. On one side, escape is still possible, though barely. On the other, all trajectories lead inward. You wouldn't feel it when you cross. There would be no flash, no resistance, just the quiet realization that all paths now point in one direction. Outward no longer exists. To a distant observer, your descent slows to a stop, frozen forever on the edge. Your light grows dim, stretched into longer and longer wavelengths until you fade completely. But from within, you continue falling smoothly, passing through that invisible boundary as time begins to stretch into eternity. Inside, the laws of physics dissolve into mystery. Distances lose meaning. Time fractures. You are no longer moving through space. You are being carried along by it, toward a singularity hidden beyond understanding. And yet, there's a strange calm here. The noise of the universe fades away. The chaos of motion stills. Even as gravity increases beyond measure, there is peace in its inevitability, a silence so complete that it feels sacred. The journey inward is not about reaching the center. It's about witnessing the edge of what can be known, crossing the threshold between the measurable and the infinite. And as your final heartbeat fades into the timeless dark, you realize you haven't fallen into emptiness. You've fallen into truth, the pure, silent geometry that underlies everything that ever was. As you fall, tidal forces grow stronger, pulling your atoms apart one by one. This is where matter ceases to be matter, where physics dissolves into poetry. At first, you might not notice. The descent feels smooth, almost serene. But as you move deeper into the black hole's gravity well, the difference in pull between your head and your feet begins to grow. The gradient of gravity becomes steep, so steep that the very structure of your body begins to stretch. You are being drawn into alignment with the invisible flow of space-time, elongated into a single, trembling thread. Physicists call this spaghettification, a name that sounds almost playful until you imagine what it means. Every part of you is being pulled at a slightly different rate. Your atoms, your molecules, even the nuclei within them, all are stretched in the direction of your fall. At the same time, the sides of your body are squeezed inward by the curvature of space itself. You are not just being torn apart, you are being reshaped by the geometry of gravity. In these final moments, the laws that govern ordinary matter begin to falter. Atoms cannot hold their bonds against forces this immense. The electromagnetic fields that keep electrons tethered to their nuclei collapse, and the particles that once formed you scatter into streams of plasma, aligning like magnetic filings along the black hole's gravitational field lines. If you could somehow remain aware, you would witness something both horrifying and beautiful. Ahead of you, the singularity burns invisibly, a point where density becomes infinite. Behind you, the universe stretches out, warped beyond recognition. The light from distant stars, bent by gravity, forms concentric rings that circle endlessly around the horizon. The cosmos itself seems to be folding inward, as if being drawn with you into the black hole's final breath. Yet, even in this violence, there is order. The same mathematical laws that describe the fall of an apple describe your disassembly. The same curvature that warps time around a planet now defines your shape as you cross the point of no return. Everything, every tear, every twist, every shimmer of radiation is still following Einstein's geometry perfectly. No signal escapes from where you are now. To an outside observer, your fall has long since frozen at the horizon, your light dimmed and redshifted into invisibility. But within your own frame of reference, you continue inward, faster and faster, though you will never feel speed. The universe around you accelerates, galaxies blur into streaks, time itself begins to unravel, seconds and eternities become the same. And then, no sensation, no pain. The distinction between body and space, between self and matter, dissolves. You have become part of the flow. Your atoms, once individual and unique, are absorbed into the continuum of space-time itself. This is the point where physics gives way to poetry, where equations meet the edge of their meaning. It is not death in the ordinary sense, because what dies here was never separate from the universe. It only returns to the geometry it came from. Spaghettification sounds like destruction, but in truth, it's transformation. The universe is reordering what you are into, what you've always been. A pattern of energy woven into the fabric of gravity's final dream. Once you cross the event horizon, no signal can escape. Yet, to you, nothing feels unusual. You continue falling, forever, into a future no outside observer will ever see. It is the most silent transition in the universe, unmarked, invisible, and irreversible. There is no flash of light, no wall, no warning. The event horizon is not a physical surface, but a boundary in geometry, a one-way edge in the fabric of space-time. You drift through it without resistance, unaware that you have passed the point from which no return is possible. Outside, the universe has already lost sight of you. To everything that remains beyond the horizon, your story has ended. Inside the horizon, all directions lead inward. Down is no longer a matter of orientation. It's a condition of existence. Space-time itself is collapsing toward the singularity, and everything within it is carried along like debris caught in a waterfall that flows through time, not space. You are not moving toward the center. You are being carried with the center as it deepens around you. From your perspective, the fall feels calm. No acceleration, no turbulence, no sense of catastrophe. The black hole is not chaos, it is precision. Every particle follows its geodesic, its path through curved space-time, perfectly defined by the laws of relativity. You are a passenger in a cosmic equation, falling through a geometry written at the beginning of time. Yet the view around you defies comprehension. The light from the universe beyond the horizon bends back upon itself, wrapping into distorted halos. You see the past and future simultaneously, overlaid like reflections in warped glass. Time and direction begin to blur. Photons that once traveled in straight lines now orbit endlessly, forming a sphere of shimmering ghosts. Images of the cosmos frozen in their last moments before falling in. Inside, causality itself changes shape. The singularity lies not ahead of you in space, but ahead in time. No path leads outward, because outward no longer exists. The flow of time has turned inward, funneling everything toward a single destination, the center where all paths meet. In a sense, you are not falling into the black hole, you are falling into the future. Physicists have long debated what truly lies beyond the horizon. Some theories suggest that the matter inside compresses to infinite density, collapsing into a singularity where the known laws of physics can no longer operate. Others propose that the core may bridge to another region of space-time, perhaps even another universe, a mirror reality connected through the curvature of dimensions we cannot yet perceive. But from within, theory doesn't matter. There is only the fall, the silence, the slow stretching of moments into eternities. No outside observer will ever witness this part of the journey. Your time is sealed from theirs, cut off by the horizon. To them, you are frozen. To you, you are infinite. And in that endless descent, something remarkable happens. The fear fades. There is no pain, no struggle, only motion and stillness combined. Beyond the horizon, you become part of the flow, an unending current of space and time, drawn toward the heart of mystery. It's not an ending, but an absorption. Beyond the horizon, individuality dissolves, and what remains is part of the fabric itself, an echo of existence continuing in the only direction left. Deeper into forever, from far away, you appear frozen at the edge, but from within, eternity unfolds in moments. Two perspectives, both true, both incomplete. Time, in the presence of gravity, is no longer a universal rhythm. It becomes personal, subjective, shaped by motion and mass. Near Sagittarius A star, that truth reveals itself with breathtaking clarity. What feels like seconds to you within the black hole's pull may appear as eons to those who remain outside. From their point of view, you never cross the event horizon. Your descent slows, then halts entirely, your final image fading to red as your light stretches across infinite time. To them, you become eternal, a frozen ember at the edge of oblivion. But within your own frame of reference, time continues smoothly. You fall without pause, There is no freezing, no distortion, no awareness that the universe beyond has already written your ending. Your watch still ticks, your pulse still beats, your perception flows onward, while the cosmos outside accelerates toward its distant future. Galaxies age, stars die, and civilizations rise and vanish, all while you are still mid-fall. This paradox is not illusion, it is the nature of reality as described by Einstein's general relativity. Time does not pass at the same rate everywhere. It bends and warps in response to gravity, woven inseparably into the geometry of space. Where gravity is stronger, time flows slower. Near a black hole, it slows to nearly nothing, and at the event horizon, for an outside observer, it stops entirely. Astronomers have seen echoes of this truth in the orbits of stars near Sagittarius A star. As they pass close to the black hole, their light shifts to longer wavelengths, a gravitational redshift, proof that time itself is stretching for them. It's as though every photon must fight its way uphill through curved spacetime, losing energy along the climb. What we observe is a whisper of slowed time translated into color. In this cosmic ballet, both perspectives coexist. From the outside, you are frozen forever. From the inside, you are moving freely. Neither is wrong. Each is bound by its own frame of reference, by the geometry that defines what now even means. Relativity teaches us that simultaneity, the idea that two events can truly occur at the same moment, is an illusion. There is no universal present. There is only your present and mine, separated by the curves of gravity and the stretch of light. Perhaps this is why black holes feel so profoundly mysterious. They don't merely challenge our understanding of space, they challenge our understanding of time, of sequence, of existence itself. What is frozen to one observer is flowing to another. What seems eternal from afar may be fleeting from within. And somewhere between these two truths lies a quiet symmetry. Both are incomplete alone, but together they reveal the beauty of relativity, that the universe has no single clock, no single tempo, but an infinite chorus of ticking hearts, each one keeping time to its own gravity. To fall toward Sagittarius A star is to experience that truth directly, to feel the fabric of time stretch like silk beneath your motion. It is to witness eternity not as endless duration, but as an instant so deep it touches forever. Around Sagittarius A star, entire star clusters orbit in perfect rhythm. The galaxy's core hums with gravitational music, a silent symphony only physics can hear. It is a concert without sound, performed on scales of millions of years. Each star, each gas cloud, each fragment of dust follows a precise trajectory, its motion dictated by gravity's unseen score. From our vantage point on the Orion Arm, we see only the faint shimmer of that distant choreography, but deep at the galactic center, the music of motion never ceases. The stars closest to Sagittarius A star, the stars, form the high notes of this cosmic composition, racing in tight, elliptical orbits that complete within a few human lifetimes. Farther out, larger and older stars move more slowly, their paths stretched into long, elegant loops. Together, they form layered harmonies, fast and bright near the core, deep and resonant farther away. It is as if the galaxy itself breathes in rhythm, expanding and contracting in gravitational time. Every motion here is a consequence of the invisible. Gravity provides no sound, yet its influence ripples through the structure of the Milky Way, like vibrations through the body of a cello. The dense clusters of stars orbiting near the center are not chaotic, they are ordered, bound by a shared tempo. Even chaos has a time signature when governed by such perfect mathematics. Astronomers have mapped these orbits with exquisite precision. Using infrared and radio telescopes, they have traced the paths of hundreds of stars, watching them drift in complex but predictable patterns. Each orbit provides another measure in the galaxy's composition, another note in the ongoing piece that has played for billions of years. If one could translate those gravitational frequencies into sound, the result would be haunting, low, resonant waves vibrating across unimaginable distances, a symphony of mass and motion echoing through space-time. The gas and dust clouds that swirl around the galactic core add texture to this composition. When they collide or compress, they create bursts of X-rays and radio waves, sudden crescendos in an otherwise steady rhythm. These energetic flares, though invisible to human eyes, are the percussion of the galactic orchestra. Short, sharp beats punctuating the slow harmony of stellar orbits. Even black holes contribute to the music. The supermassive heart of Sagittarius A star produces faint, rhythmic pulses, radio flares, and gravitational ripples that act like a deep, hidden bass line. Each pulse is spaced across minutes or hours, but when combined across eons, they merge into the steady hum of the galaxy itself. From Earth, we cannot hear it, but our instruments can. The signals that reach us, radio waves, infrared flickers, bursts of X-ray light, are the score translated into a form we can read. In that data, in those delicate variations of frequency and brightness, lies the structure of a living galaxy. And perhaps, if we listen closely, we can feel it too. Every planet, every moon, every atom participates in that silent symphony. The music of Sagittarius A star is not something happening out there. It's happening everywhere, including here, right now, in the quiet pulse of existence. We are part of that orchestra. A single note, brief and small, in a masterpiece billions of years long, at wavelengths invisible to our eyes, Sagittarius A star whispers. Each radio wave carries the story of collisions, magnetic storms, and matter consumed in silence. Long before we ever saw its shadow, we heard its voice. In the early 20th century, astronomers tuning radio antennas toward the constellation Sagittarius detected a faint hum, a steady emission unlike any known star or planet. It pulsed not in light, but in radio waves, low and ancient, as if the galaxy itself were exhaling through static. This invisible rhythm became our first real clue to the existence of a supermassive black hole at the Milky Way's core. Today, with instruments like the Atacama Large Millimeter Array, ALMA, and the Very Large Array, VLA, that whisper has become a conversation, subtle but full of meaning. The radio signals from Sagittarius A star flicker and shift, rising and falling as bursts of plasma spiral close to the event horizon. These emissions are the signatures of turbulence, where magnetic fields twist and reconnect, hurling energy outward before gravity swallows it again. Each flare is a word in a language we're still learning to interpret. Sometimes it comes as a soft murmur, a gentle increase in radio brightness lasting minutes. Other times it erupts suddenly, a powerful surge that echoes across multiple wavelengths. The black hole does not roar or scream, it breathes, speaking in the electromagnetic tones of a cosmic heart. The beat of this heart comes from the rotation of hot gas in the inner accretion disk. As plasma accelerates near the speed of light, it emits synchrotron radiation, charged particles spiraling through magnetic fields, producing radio waves that travel across the galaxy. These signals, faint yet persistent, reach Earth after a journey of 26,000 years, carrying the ancient fingerprint of space-time under strain. To the human ear, they would not sound like music but like wind, a shifting hiss, a chorus of frequencies blending and fading. Yet hidden in that noise are patterns, periodic fluctuations, harmonics, and cycles. They hint at order beneath the chaos, at the possibility that even in the most violent regions of the cosmos, there is rhythm. Radio telescopes act as our stethoscopes, pressed gently against the chest of the galaxy. Each observation reveals more about the environment near Sagittarius A star, its spin, its temperature, its magnetic architecture. When multiple observatories around the globe combine their data, the result is a portrait drawn not in light but in signal, a map of energy dancing around darkness. Occasionally, the black hole grows quiet, entering long stretches of stillness. Then, without warning, a flare returns, brighter and sharper than before. It's as if something deep inside has stirred, a heartbeat quickening after silence. These moments remind astronomers that Sagittarius A star is not static but alive, with cycles of feeding and resting, expansion and calm. What makes these whispers profound is not just their scientific value, but their intimacy. Light can dazzle, but radio waves feel personal, soft, persistent, reaching us long after the visible world has faded. They remind us that even in the deepest voids, energy moves, stories are told, and time keeps its rhythm. The radio heart of the galaxy beats quietly, endlessly, and though we cannot hear it with our ears, we are, in some way, tuned to it, our atoms, our orbits, our very sense of time, all resonating faintly with the same cosmic pulse. Invisible lines of magnetism twist and snap across the core, shaping the motion of plasma like invisible puppet strings. Energy, bound by geometry. At the center of the Milky Way, gravity may rule, but magnetism gives form to the chaos. Around Sagittarius A star, invisible magnetic fields lace through space, guiding the flow of charged particles and shaping the behavior of the accretion disk. They are unseen architects, threading energy into structure, drawing order from turbulence. Like spider silk woven through darkness, these fields stretch for light years, connecting clouds of gas, bursts of radiation, and the very heartbeat of the galaxy itself. We only began to see their true beauty recently. In 2021, using the Event Horizon Telescope's polarized light imaging, astronomers revealed something extraordinary: the black hole's magnetic field made visible for the first time. The glowing ring around Sagittarius A star wasn't just light, it was light twisted. Polarized radiation traced the alignment of magnetic field lines swirling around the event horizon, revealing a complex, spiraling pattern. It was as if the black hole's immense gravity was braiding light and magnetism together into a single, luminous tapestry. Inside the accretion disk, these fields perform a violent ballet. As plasma orbits at nearly the speed of light, tangled magnetic loops snap and reconnect in bursts of energy, known as magnetic reconnection events. When they do, they unleash flares powerful enough to be seen across the galaxy. These are the sparks of creation and destruction intertwined, moments when the stored tension in the field is converted into heat, light, and radiation. To the human eye, this dance is invisible, but through radio and X-ray observations, it becomes a living pattern. Magnetic arches rise and collapse like waves in slow motion, shaping how gas flows toward the black hole. In some regions, these lines of force even resist gravity's pull, channeling material outward instead of letting it fall in. This resistance may explain the faint jets and outflows we detect from Sagittarius A star, narrow streams of plasma pushed away from the black hole by magnetism, strong enough to bend the rules of gravity itself. But magnetism here is more than just force, it is form. The black hole's spin twists the field lines into helical spirals, warping them into intricate loops that stretch far beyond the accretion disk. Each line is like a thread in a cosmic loom, weaving motion into structure. The patterns change constantly, like the shifting auroras of a planetary sky, only scaled to billions of kilometers and powered by gravity's deepest well. Scientists call this region the magnetosphere, but the term hardly does it justice. It is not a fixed field but a living system, self-sustaining, dynamic, full of tension and release. Its strength varies over time, waxing and waning with the inflow of matter. When gas clouds approach the black hole, the magnetic web tightens, its lines glowing brighter in polarized light before snapping and reforming anew. In the end, the magnetic web is what gives the void its rhythm. Gravity may draw everything inward, but magnetism decides how. Twisting, shaping, guiding the fall like an unseen hand. Together, they turn destruction into art, chaos into pattern, darkness into energy. The black hole's magnetic field is a paradox made visible, a structure with no solidity, a shape made only of force. It is a reminder that even in the deepest gravity wells, there is elegance, and that the universe, at every scale, builds its beauty on invisible lines of connection. Black holes destroy, but they also give. jets of radiation and charged particles stream outward, seeding the galaxy with elements that become stars, planets, and life. It's easy to imagine Sagittarius A star as a monster, consuming everything that dares to come near. Yet, the truth is far more complex and more beautiful. Even as it devours matter, the black hole releases energy in vast, luminous outflows. These are the winds of creation, streams of plasma, radiation, and high-energy particles that escape the edge of the accretion disk and race outward at nearly the speed of light. They carry with them the ashes of what once was, recycled material that will one day help form new worlds. These winds arise where magnetic fields and gravity collide in violent harmony. As matter spirals inward, some of it is caught in magnetic loops twisted by the black hole's spin. Instead of falling all the way in, it's flung outward through narrow channels perpendicular to the disk, relativistic jets. Beams of plasma so powerful they can pierce the interstellar medium across thousands of light years. Even our relatively quiet Sagittarius A star shows signs of this process. Faint radio lobes and gamma-ray bubbles ballooning from the galactic center, each spanning over 25,000 light-years. These enormous structures are evidence that our black hole once released a breath of creation that reshaped the Milky Way. The energy in these outflows stirs the galaxy's heart. As the jets plow through the surrounding gas, they compress it, triggering the birth of new stars. What was once torn apart by gravity becomes the seedbed for future light. Even destruction, at this scale, fuels renewal. The carbon in our bodies, the oxygen we breathe, the metals that form planets, all trace their ancestry to such cycles. Black holes are not merely endpoints, they are engines of transformation, cosmic recyclers that ensure matter never truly disappears. If you could see these winds with your eyes, they would appear as ghostly blue flames, flickering and stretching across the void. They do not burn with heat, but with motion, charged particles spiraling along magnetic fields, emitting radiation as they twist through the galactic halo. The glow they leave behind lingers for millions of years, like embers in the vast fireplace of the Milky Way. Even now, Sagittarius A star exhales faintly. Sensitive instruments detect subtle flows of gas being pushed outward, evidence that, though mostly dormant today, it still breathes. In the past, when it was younger and hungrier, these winds may have been far stronger, shaping the very structure of the galactic core. The bubbles above and below the plane of the Milky Way, the so-called Fermi bubbles, are likely relics of that ancient storm, still expanding, still radiating energy from an eruption that occurred millions of years ago. In that sense, black holes are not the end of creation but one of its engines. They are the galaxy's lungs, drawing matter inward and releasing it again in a cycle that stretches across eons. What they consume, they return, changed, energized, spread like cosmic pollen into the surrounding darkness. The next generation of stars will form from these winds. Around those stars, planets will take shape. And on some of those worlds, perhaps, life will emerge, built from atoms that once brushed the edge of Sagittarius A star, that once danced in the magnetic winds of a black hole's breath. Destruction and creation are not opposites here. They are the same act, seen from two different sides of time. The black hole inhales the universe, and the universe exhales through it, an endless rhythm of death turned into life, and silence turned into light. The same force that devours light also births galaxies. Sagittarius A star is both a grave and a cradle, a contradiction that defines existence itself. At first glance, a black hole seems to be the end of all things, a cosmic predator that consumes without mercy, leaving only silence behind. Yet when we look closer, we find that its influence extends far beyond the reach of destruction. It sculpts galaxies, powers star formation, and breathes energy into the vast interstellar void. Sagittarius A star is not merely a tomb, it is an architect, shaping the Milky Way with every act of consumption. This paradox lies at the heart of astrophysics. The same gravity that swallows light is also the gravity that binds galaxies together. Without supermassive black holes anchoring their centers, galaxies might never have formed at all. Their pull stabilizes the swirling chaos of stars and dust, keeping everything in orbit around a single, silent core. Remove that gravity, and the spiral would unravel. The Milky Way would dissolve into a shapeless sea of drifting light. But the story goes deeper. When Sagittarius A star feeds, even slightly, it releases immense energy. Gas drawn toward it doesn't vanish quietly, it shines. As matter accelerates near the event horizon, it converts gravitational potential into radiation, emitting powerful flares of X-rays and infrared light. These outbursts heat and compress the surrounding gas, triggering the collapse of distant clouds that will one day ignite as new stars. Thus, in consuming matter, the black hole gives birth to more. It is an endless feedback loop, the balance of chaos and creation. Black holes regulate the growth of galaxies much as a heart regulates blood flow. If Sagittarius A star were to feed too rapidly, its radiation would blow away the gas needed for stars to form, halting creation entirely. If it were too quiet, gas would accumulate unchecked, leading to runaway starbursts that could tear the galactic core apart. The black hole's intermittent hunger, its cycles of dormancy and feeding, sustain equilibrium on a cosmic scale. Even our own sun owes part of its existence to this paradox. The atoms that built it, hydrogen, carbon, oxygen, iron, were forged in earlier generations of stars whose formation was influenced by the energy outflows of ancient black holes. Every planet, every living being, every breath of air is a byproduct of that balance between consumption and renewal. It's as though the universe insists that creation must always carry a trace of destruction, that life itself emerges from the remnants of what came before. Sagittarius A star embodies that truth perfectly. Its gravity devours stars, yet its influence ensures new ones will rise. Its darkness defines the galaxy's structure, yet within that darkness lies the spark of light. Perhaps this is the deeper lesson hidden within the black hole's paradox, that endings are illusions. Every act of destruction releases energy, and every burst of energy becomes the foundation for something new. What disappears into Sagittarius A star doesn't vanish from the universe, it transforms, redistributed across time and space. In this way, the black hole is not a contradiction but a reflection, a mirror of the universe's own design. To create, something must first be unmade. To shine, something must fall into shadow. And at the heart of our galaxy, that eternal exchange continues. The cycle of birth through annihilation, order through entropy, existence through surrender. Sagittarius A star is not just the galaxy's endpoint. It is its beginning, repeated endlessly, written in the gravitational poetry of creation through destruction. Infrared eyes pierce the veil of dust that hides the galactic center. Beneath the darkness lies a swirling city of stars, ancient suns orbiting a hunger that never sleeps. To the naked eye, the center of our galaxy is invisible. The Milky Way's heart is shrouded behind vast clouds of interstellar dust, dense regions of carbon, silicates, and ice that block visible light entirely. Even the brightest stars are swallowed by the haze. For centuries, that darkness was thought to be empty space, an unseeable void. But when astronomers turned infrared telescopes towards Sagittarius A star, the truth emerged. Beneath that cosmic curtain lies one of the most crowded, energetic, and dazzling regions in the known universe. Infrared light can pass through dust that stops ordinary starlight, and through it, astronomers have mapped a glowing metropolis of stars, orbiting the supermassive black hole in tight, intricate loops. It is a place of density almost beyond comprehension, where 1 million stars occupy a space barely a few light years across. Each one burns brighter and faster than our sun, caught in the black hole's gravitational grip, their light swirling together into a hazy golden sea. This region, known as the Galactic Center Cluster, is home to some of the most extreme stellar environments ever observed. Giants and dwarfs, young blue stars, and ancient red ones coexist in a gravitational storm. Some were likely born here, condensed from gas clouds compressed by Sagittarius A star's magnetic influence. Others may have migrated inward from the spiral arms, drawn toward the core by the subtle tug of the galaxy's mass. Together, they form a luminous mosaic, a stellar city built around darkness. Among these stars drift vast ribbons of gas and dust, filamentary structures shaped by winds from dying suns and the gravitational tides of the black hole itself. In visible light, they are impenetrable shadows. In infrared, they glow faintly, like smoke backlit by starlight. They twist and weave into spirals and arcs, evidence of constant motion. The galactic center is not static. It breathes, shifts, and pulses as energy and matter circulate through its depths. The James Webb Space Telescope, JWST, has given us an even clearer view of this hidden world. In its deep infrared imagery, the galactic core appears not as a void, but as an ocean of molten color, golden currents of dust, pink clusters of starbirth, and dark scars carved by ancient explosions. Each glowing filament is a thread of history, linking the past to the present in patterns only visible to instruments that can see beyond the limits of human sight. Through these images, we glimpse the ongoing relationship between creation and concealment. The dust that hides the galactic center also nourishes it. Those same grains that block visible light contain the raw material for stars and planets. They are cosmic soil, recycled matter from earlier generations of stars that burned, died, and scattered their ashes into space. From that dust, new suns emerge, glowing once more in a cycle that has continued for billions of years. The more we study this region, the more it feels alive. Waves of radiation, magnetic fields, stellar winds, and light all interplay in an intricate balance. The darkness is not absence, it is density, an overwhelming abundance of material and motion compressed into one shining core. And so, the veil that once seemed empty is revealed to be full beyond measure. The dust conceals, but it also connects. The glow reveals, but it also blinds. Together, they remind us that in the universe, beauty often hides in shadow, and that every obscured horizon may only be waiting for the right kind of light to be seen. Some of these stars are nearly as old as the galaxy itself, survivors of cosmic violence, circling a predator that has existed since the beginning. They are the ancient ones, old, dim suns that have watched the Milky Way evolve from a young spiral into the vast, mature galaxy we see today. Their light began shining when the universe was still in its youth, when galaxies were colliding, merging, and finding their forms. Now, billions of years later, they continue to orbit Sagittarius A star, survivors in a region where few things endure. Most stars that wander too close to the galactic core are either torn apart or swallowed whole. Yet these ancient suns persist, tracing slow, majestic ellipses through space, warped by gravity and time. They are not the blue-white furious stars that race around the black hole in decades, but cooler, redder, quieter lights, embers rather than flames. Their patience has outlasted civilizations, epochs, and eons of cosmic change. Astronomers have identified several populations of stars near Sagittarius A star, and among them are those that formed when the Milky Way itself was still assembling. These old stars bear chemical fingerprints that mark them as primordial, low in heavy elements, rich in hydrogen and helium, their compositions untouched by generations of stellar recycling. They are fossils of the early cosmos, carrying within their light the memory of a universe not yet crowded with complexity. Surrounding them are younger stars, formed much later, perhaps triggered by waves of energy from Sagittarius A star's periodic feeding. The contrast between the young and the old here is striking. Youthful blue stars blazing at thousands of times the sun's luminosity, and ancient red giants burning low and steady, both circling the same abyss. The galactic core is a meeting point of timescales, a place where the past and present coexist in a single gravitational frame. To survive for billions of years in such a violent neighborhood requires resilience and luck. Some of these elders likely formed farther out, only later migrating inward through gravitational interactions with other clusters. Others may have been born in situ, forged from the same dense gas clouds that once surrounded the growing black hole. In either case, they have endured through tidal waves of radiation, through the collapse of nearby stars, through bursts of X-rays that could strip atmospheres and destroy worlds. And yet they remain, ancient witnesses orbiting a timeless center. In their dim red light lies a quiet dignity. Unlike their younger, hotter neighbors, these old stars do not burn quickly or brightly. They conserve their fuel, glowing with steady persistence like candle flames in a storm. Some have already begun to shed their outer layers, creating expanding shells of dust that shimmer faintly in infrared light, a final act of giving before they fade. If one could stand near these stars and look out, the view would be unlike anything else in the galaxy. The sky would be crowded with light, thousands of stars shining so close together that darkness would barely exist. Yet, at the center of that brilliance, a black void would dominate the heavens. Sagittarius A star, silent and immense, the ancient companion of all who orbit it. These stars remind us that survival in the universe is not just a matter of strength, but of balance. They have endured by finding stability within motion, harmony within danger. For billions of years, they have circled the same darkness, unhurried, unbroken, and unafraid. And perhaps that is why they are still here, because even in the shadow of a black hole, they have learned what it means to endure. They are the galaxy's oldest storytellers, and in their steady light, the past of the universe still burns. Between flares of plasma and radiation lie regions colder than space itself, where molecules drift in frozen silence, a contrast only the universe could invent. The galactic center is often imagined as a realm of constant violence, a seething storm of heat, gravity, and light. But hidden between those bursts of chaos are zones of unimaginable stillness. Just beyond the glowing accretion disk and the feverish activity of the inner core, vast clouds of gas and dust drift in temperatures barely above absolute zero. It is a paradox sculpted by physics itself. The closer you come to the hottest region of the galaxy, the more islands of cold you find. These are the molecular clouds of the galactic center, enormous reservoirs of hydrogen, carbon monoxide, and other complex molecules that serve as the raw material for future stars. Some stretch for dozens of light years, their interiors shielded from the harsh radiation around Sagittarius A star by thick walls of dust. Within those shadows, light cannot penetrate, and heat cannot easily escape, allowing temperatures to drop to just a few degrees above absolute zero, colder even than the faint cosmic background that fills intergalactic space. If you could drift through one of these frozen clouds, it would feel more like moving through fog than vacuum. The gas would be thin enough to make breathing impossible, but dense enough that light would diffuse softly around you. Particles of ice and silicate dust would glimmer faintly, illuminated by the distant glow of the galactic core. In that darkness, time seems to slow. Molecules tumble lazily, colliding once every few years, forming the first fragile compounds that may one day become part of stars, planets, and even life. Astronomers studying these regions through infrared and submillimeter telescopes have discovered that they are far from empty. Within their depths lie pockets where gravity begins to take hold, compressing the gas into dense knots that will eventually collapse into new stars. In these frigid environments, the seeds of creation are sown. The same black hole whose radiation scorches nearby matter also contributes to the formation of these clouds, stirring them with tidal forces and shock waves that set their contents into motion. It's a delicate balance, a cosmic tension between heat and cold, destruction and genesis. When Sagittarius A star flares, it bathes these clouds in X-rays and ultraviolet light, stripping away their outer layers and revealing their luminous edges. When it quiets, the radiation fades, and the clouds heal, growing denser and darker again. This rhythm creates a cycle of erosion and renewal that has persisted for billions of years, feeding the galaxy's heartbeat. In the coldest regions, where starlight cannot reach, chemistry takes on an almost poetic patience. Molecules of water, ammonia, and methane freeze onto grains of dust, forming icy mantles that preserve them for millennia. Some of these compounds may be older than our solar system, having drifted near the galactic core since long before Earth existed. When they are finally swept into new stars or planets, they carry with them the memory of this frozen frontier, ancient molecules that will one day melt again in the warmth of newborn suns. The cold near the galactic center is not emptiness, it is potential waiting to ignite. Each quiet region is a pause between beats, a breath between flares. The contrast it creates, heat beside stillness, light beside shadow, is what gives the galaxy its shape and rhythm. In that way, these frozen zones remind us that the universe's most profound creativity often hides in its quietest places. Between the fires of destruction, the seeds of renewal gather in silence, waiting for the next dawn of stars. At the center of Sagittarius A star lies a point smaller than an atom, yet containing millions of suns, a paradox of density so profound that physics itself stops speaking. This is the singularity, the place where all paths, all matter, all equations converge. Everything that falls into the black hole, every atom, every photon, every moment of time, collapses toward this single point. Here, the very concept of space loses meaning. There is no inside or outside, no direction to fall, no surface to touch. The universe, as we understand it, ends not with a boundary, but with an idea so extreme that even mathematics trembles. General relativity predicts the singularity's existence, yet it cannot describe it. According to Einstein's equations, once matter is compressed past a certain threshold, space-time curves infinitely. Density without limit, curvature without form. Gravity becomes so strong that it disconnects this region from the rest of the universe. Nothing escapes, not even information. To ask what lies at the singularity is like asking what lies north of the North Pole. It's not just hidden, it's undefined. And yet, we suspect there's more to the story. Physics rarely tolerates infinities. They are signs of incomplete understanding. Somewhere beyond relativity, in the domain of quantum gravity, there must be an explanation, a way to describe what happens when the vast meets the vanishing. Some theories suggest that the singularity is not a point at all, but a region of warped space-time where quantum fluctuations create a storm of energy. Others imagine it as a bridge, connecting to another universe entirely, a doorway hidden inside the deepest shadow. The singularity is, in a sense, the most private place in existence. Every particle that crosses the event horizon joins this eternal collection, but its individuality is erased. Mass adds to mass, spin adds to spin, charge adds to charge, but the details vanish. It is the universe's most efficient eraser, reducing complexity to simplicity, diversity to unity. From the outside, all that remains are three numbers: mass, spin, and charge. Everything else, every atom, every story, becomes indistinguishable. What, then, becomes of time itself? Inside the horizon, the roles of space and time reverse. Time becomes the direction of fall, and all paths lead toward the singularity as inevitably as seconds flow into minutes. You cannot stop moving forward, because forward no longer means distance, it means existence itself. The singularity is not just a place where matter collapses, it's where the concept of before and after collapses too. For decades, physicists have searched for a theory that unites quantum mechanics and general relativity, two pillars of understanding that cannot currently coexist at the singularity. Some hope that quantum gravity will reveal the true nature of this hidden point, perhaps showing that the singularity is finite, a knot of space-time rather than an infinitude. Others suggest that what we call a singularity might be an illusion, the result of our equations reaching their limits. Whatever the answer, the singularity's mystery persists. It sits at the core of every black hole, an unsolvable line of code written into the operating system of the cosmos. It is both the smallest thing and the largest mystery, the end of physics and perhaps its beginning. In that paradox lies its beauty. The singularity reminds us that the universe still holds secrets too deep for even our brightest minds to reach. It whispers that beneath every law and constant, there may be a deeper order, one that connects destruction and creation, space and time, being and nothingness. And though we may never see it, the singularity remains there, silent, patient, eternal, a point of infinite possibility waiting at the end of all understanding. Black holes aren't just holes in space, they're holes in time. What falls in doesn't just vanish, it becomes part of space-time's memory. To stand at the edge of a black hole is to stand at the boundary of history itself. Outside the event horizon, time still unfolds, moments stack upon one another, cause leads to effect, and the arrow of time moves forward as we understand it. But as you approach that invisible line, time begins to stretch and warp, until forward and backward lose distinction. Cross it, and you don't simply move deeper into space, you move deeper into the future. Einstein's general relativity tells us that gravity and time are inseparable. The stronger the gravitational field, the slower time flows. At Sagittarius A star, that effect reaches its ultimate limit. For an outside observer, anything falling toward the event horizon appears to slow infinitely, its clock grinding to a halt just before crossing. But from the falling object's perspective, time continues normally, smooth, uninterrupted, inevitable. It passes through the horizon and keeps going, while the rest of the universe races ahead, unseen. This duality creates one of the most haunting paradoxes in all of physics. To the rest of the cosmos, the black hole's surface holds every moment of its past, frozen in redshifted light. Each photon, emitted from a falling object, stretches longer and longer until it fades into darkness, trapped forever at the edge of visibility. The event horizon becomes a cosmic memory, recording every fall, every motion, every trace of matter that has ever crossed its threshold. And yet, for what lies beyond, that record no longer exists in any meaningful sense. The information that made up the falling object, its structure, its patterns, its history, is absorbed into the curvature of space-time itself. The black hole grows slightly more massive, its horizon slightly larger, its gravity slightly stronger. The universe remembers, but only in weight, not in detail. Physicists often describe black holes as one-way time machines. From the outside, we see time freeze. From the inside, all roads lead forward, toward the singularity. There is no turning back, no pause, no escape. To fall into a black hole is to step across the ultimate event horizon of time, beyond which the past and future cease to have separate meaning. But what if the black hole does not truly forget? Quantum theory insists that information cannot be destroyed, only transformed. Some physicists believe that the event horizon acts like a storage surface, encoding everything that falls in as faint vibrations in space-time. According to this view, the black hole is not a void but a library written in gravitational code, its pages made of the fabric of the universe itself. If that's true, then nothing is ever truly lost. Every atom, every photon, every heartbeat that has ever fallen into Sagittarius A star still exists in some form, woven into the ripples of space-time, stretched thin but not erased. The black hole becomes not a destroyer of time, but its archivist, preserving the past in a language we have not yet learned to read. Perhaps that is what makes black holes so haunting. They don't end stories, they store them. They hold the record of the universe's own evolution, compressed into a horizon that marks the edge of knowing. Time's event horizon is not simply where things end, it is where they are remembered. And though we can never cross it and return, we can still listen to its whispers in radiation, in gravity, in light bent by memory. In that way, every black hole becomes a monument to time itself, a place where the past still exists, not in form, but in echo. Does the universe forget what enters a black hole? Or does it keep every secret encoded in the faint radiation that seeps out across eons? This is one of the greatest puzzles in all of physics, the information paradox. It began with a simple question. If nothing can escape a black hole, what happens to the information carried by the matter that falls in? Every atom has a quantum signature, a unique fingerprint of position, energy, and spin. According to the laws of quantum mechanics, this information can never be truly lost. Yet black holes seem to erase it completely. When Stephen Hawking applied quantum theory to black holes in the 1970s, he made a stunning discovery. Through a subtle process near the event horizon, black holes are not entirely black. They emit a faint glow, now known as Hawking radiation, as pairs of virtual particles flicker into existence, one falling in while the other escapes. Over unimaginable timescales, this radiation would cause a black hole to slowly evaporate until nothing remains. But here lies the paradox. Hawking radiation appears to be purely random. It carries no trace of the matter that once fell in. If true, this would mean that black holes destroy information, something forbidden by the most fundamental principles of physics. It would mean that the universe can forget. For decades, scientists wrestled with this contradiction. On one hand, relativity insists that whatever crosses the event horizon is gone forever. On the other, quantum mechanics insists that nothing is ever truly erased. The two great pillars of modern science, each flawless within its own domain, collide at the edge of a black hole. Somewhere between them lies a missing piece, a bridge between gravity and quantum theory. Some researchers believe that information isn't lost, but encoded on the black hole's surface. This idea, known as the holographic principle, suggests that everything swallowed by a black hole is preserved as quantum vibrations on the event horizon, a two-dimensional record of three-dimensional events. In this view, the black hole functions like a cosmic projector. Reality inside the horizon is a hologram, a lower-dimensional imprint that still contains every detail. Others think information may leak out slowly with Hawking radiation itself, hidden in subtle correlations between escaping particles. If so, the black hole doesn't destroy memory, it just releases it at a pace so slow that it takes longer than the age of the universe to notice. And there are even deeper possibilities. Some physicists propose that the interior of a black hole could be connected to another region of space-time, perhaps even another universe, where information continues to exist, out of reach but not gone. The event horizon, then, might not be a wall, but a bridge, a place where information transforms rather than ends. In 2004, Hawking himself revised his position, suggesting that information might indeed escape in a subtle way, encoded in the quantum ripples of space-time. The paradox, however, remains unresolved, a mirror held between two incomplete theories, each reflecting a different truth about the same mystery. What makes the information paradox so haunting is not just what it says about black holes, but what it implies about reality itself. If information is never truly lost, then everything that has ever existed, every star, every atom, every thought, still leaves a trace in the universe's vast memory. But if information can vanish, then the cosmos is not a perfect archive, but a living story that forgets as it writes. Perhaps, like all great paradoxes, the answer is both. Perhaps the black hole neither forgets nor remembers, but transforms. What falls in may not return in form, but its essence, its energy, its pattern, its echo, continues to shape space-time long after the matter itself is gone. In that way, Sagittarius A star is not just a void, it's a cosmic mind, absorbing, processing, and radiating information across eons. A place where knowledge doesn't die, but becomes part of the universe's most mysterious form of memory. Stephen Hawking proposed that black holes slowly evaporate, releasing particles in a soft glow. In 1974, with only a pen, paper, and the mathematics of quantum fields, Stephen Hawking redefined the nature of the universe's most mysterious objects. Until that moment, black holes were seen as cosmic prisons, places from which nothing, not even light, could escape. But Hawking dared to ask, what if the vacuum of space, which quantum theory tells us is never truly empty, behaves differently near an event horizon? What if black holes, too, must obey the laws of quantum mechanics? According to his calculations, pairs of virtual particles, tiny fluctuations that constantly appear and vanish in the quantum foam, can form right at the edge of the event horizon. Normally, these pairs annihilate instantly, leaving no trace. But near a black hole, one particle can be pulled in while the other escapes. The escaping one becomes real, carrying away a tiny bit of the black hole's mass energy. To a distant observer, the black hole appears to emit a faint, steady radiation. This process is extraordinarily slow. For a black hole the mass of our Sun, it would take over 10 to the power of 67 years, many trillions of times the current age of the universe, to evaporate completely. For Sagittarius A star, with its 4 million solar masses, the timescale is even more unfathomable. 10 to the power of 87 years. To put that into perspective, by the time it fades, every star will have burned out, every galaxy will have dissolved, and the universe itself may be a cold sea of darkness. And yet, through it all, the black hole will continue to whisper, softly, steadily, its final message into the void. Hawking's discovery bridged the worlds of the cosmic and the quantum. It showed that black holes aren't absolute. They have temperature, entropy, and lifespans. They are thermodynamic objects, governed by the same physical principles that describe everything else in the cosmos. His equations revealed a stunning truth. The darker something appears, the more quietly it glows. Even the deepest shadow contains light. This faint radiation, though undetectable for now, has profound implications. It means that black holes are not eternal. They evolve, they change, they fade. The energy they emit comes at the cost of their own mass. Bit by bit, their gravity weakens. In their final moments, long after all stars are gone, they will evaporate completely, releasing one last burst of high-energy radiation, a cosmic sigh marking the end of an era. But perhaps the most poetic aspect of Hawking's whisper lies not in its physics, but in its symbolism. His work suggested that the universe is never truly silent, that even in its darkest corners, something is always happening. Information, energy, and motion persist, even when all seems lost. A black hole's whisper is the cosmos reminding itself that nothing, no matter how massive, how final, can last forever. Some physicists now think Hawking radiation may carry faint imprints of information, subtle patterns revealing what the black hole once consumed. If true, then even in its death, the black hole is not destroying but retelling its history, one quantum particle at a time. So the next time you look up into the quiet night, imagine that somewhere, in a place where light itself cannot return, a black hole is softly glowing, whispering across eternity. It's a soundless message, written in the oldest language of all, energy transforming, even at the end of everything. The universe, as Hawking revealed, does not end in silence. It fades with a whisper, a gentle reminder that even darkness burns. Some theories suggest that black holes could connect distant regions of space-time, wormholes, tunnels through the cosmos. Sagittarius A star might be one mouth of a bridge we can't yet cross. It sounds like the stuff of dreams, or of science fiction. A hidden passage through the universe, a shortcut between stars, or even galaxies. But buried within Einstein's equations lies the mathematical possibility of such pathways, known as Einstein, Rosen bridges, or more commonly, wormholes. If space-time can bend and twist, why not fold? Why not connect two distant points through a tunnel curved by gravity itself? In theory, every black hole could be a doorway, a point where space and time curve so intensely that they touch another part of the cosmos. In this vision, Sagittarius A star might not simply be a sink, but an entrance, a cosmic drain that leads somewhere else. On the opposite side, there could exist a white hole, a theoretical object that does the opposite of a black hole, expelling matter and energy instead of consuming it. The two together would form a bridge, a tunnel through the universe where time and distance collapse into geometry. Of course, such bridges may be fleeting, unstable, or purely mathematical. Classical physics tells us that any attempt to pass through a wormhole would cause it to collapse instantly under its own gravity. The pressures and tidal forces inside would destroy anything long before it reached the other side. But quantum theory, once again, whispers a different possibility. That the fabric of space-time may not be smooth at all, but frothy, like foam. In this quantum foam, countless microscopic wormholes may flicker in and out of existence every instant, connecting points in space-time on the smallest imaginable scales. Some physicists have suggested that under the right conditions, perhaps with exotic forms of matter that resist gravity's pull, these wormholes could be stabilized, stretched, and even traversed. The energy required would be immense, likely beyond anything nature or technology can currently produce. And yet, the idea lingers, because the math allows it, and the universe, as history has shown, often turns our impossible into inevitable. If Sagittarius A star were one end of such a bridge, what would lie beyond? Another galaxy? Another universe? Or perhaps a mirror reflection of our own, an echo on the far side of reality? The thought itself humbles. What we call a black hole might not be an end, but a fold in the map of existence. Matter, light, even information could, in theory, re-emerge somewhere beyond our cosmic horizon, reborn, displaced, or transformed. Even if wormholes remain purely hypothetical, their existence reminds us that space is not an empty void, but a living fabric, capable of shapes we can barely imagine. The curvature around Sagittarius A star may not simply trap light, it might weave it. The swirling accretion disk, the magnetic fields, the bending of space-time, all could be part of a geometry that extends far beyond what our senses can perceive. Einstein once wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. If space-time is connected by hidden bridges, perhaps the same is true of here and there, of one galaxy and another. The universe might not be a vast expanse to cross, but a single surface folded upon itself, its most distant regions touching in ways we cannot yet see. For now, Sagittarius A star remains a silent gate, its secret passage, if it exists, locked by physics itself. But the idea endures because it speaks to something deeply human. The hope that there is more beyond every horizon, that even the darkest void might be a doorway waiting to open. And if that bridge truly exists, then somewhere, far beyond time's reach, the Milky Way might already be connected to another sky, another world, another version of us, through the quiet gravity of Sagittarius A star. If something could survive the fall, where would it emerge? Another universe? Another time? Theoretical physics offers no certainty, only possibilities. To imagine passing beyond Sagittarius A star is to leave behind not just distance, but meaning itself. Inside the event horizon, all paths lead inward. All futures end at the singularity. Yet some theories dare to ask, what if that singularity isn't an end at all, but a passage? What if, when matter collapses into infinite density, it doesn't disappear, but tunnels through to somewhere else? This is the dream of cosmic rebirth, the idea that black holes may seed new universes. In this view, what falls in doesn't die, but transforms, carrying the information of one cosmos into the birth of another. Each black hole could be a kind of cosmic womb, giving rise to a universe of its own, its physical constants and laws subtly altered, a cascade of realities branching endlessly from the fall of matter into gravity's deepest well. It's a concept that sits at the edge of science and philosophy. Our equations can't yet describe what happens beyond the singularity. They fracture under infinities. But when physicists try to reconcile quantum mechanics with gravity, strange symmetries begin to appear. Space and time might not vanish inside a black hole. They might invert, What looks like a collapse from one perspective could appear as an expansion from another. In this sense, the other side of Sagittarius A star might look not like death, but like a Big Bang, the beginning of a new space-time, blooming outward from the compression of the old. Some cosmologists even speculate that our own universe may have been born from such a process, that what we call the Big Bang was, in truth, the other side of a black hole in a parent universe. In that scenario, the constants of nature, light speed, gravity, the charge of the electron, are genetic traits, passed down through cosmic generations. Our black holes, in turn, may give birth to new universes, each one subtly different, like offspring in an infinite family tree. But even if black holes are not cosmic cradles, they still challenge our understanding of continuity. For an observer falling inward, the experience is smooth. The laws of physics hold, even as time stretches and the outside universe accelerates toward eternity. To them, the crossing feels uneventful until the equations break. The singularity is the ultimate horizon, the place where knowledge ends, where certainty dissolves into possibility. What lies beyond may not be another place at all, but another kind of existence, a region where the familiar dimensions of space and time cease to apply, replaced by something we cannot yet imagine. Our instruments can't look that far, our math can't reach that deep, but the silence beyond Sagittarius A star still feels alive with potential, as if reality itself continues there in a different language. The idea of emergence on the other side is, perhaps, less about physics than perspective. Black holes remind us that endings and beginnings may be the same phenomenon, seen from different directions. What we call collapse might, from another vantage point, look like creation. Every fall could be a kind of flight, every disappearance a transformation. And so we look at Sagittarius A star and wonder, not if something comes out the other side, but if, in some deeper way, we already have. Perhaps every spark, every star, every consciousness is a reflection born from a universe that once fell into its own dark heart. Perhaps the abyss doesn't consume, it recreates. If so, then somewhere beyond that silent horizon, in a place no signal can reach, another sky is unfolding, its stars rising for the first time, illuminated by the echoes of what fell through long ago. From our position in the Orion Arm, the center glows faintly through interstellar dust, a hazy band of starlight and mystery 26,000 light-years away. On a clear, moonless night, far from city lights, the Milky Way stretches across the sky like a pale river. Its glow is ancient, composed of billions of unresolved stars, and if you follow that river toward the constellation Sagittarius, you are looking toward the galaxy's heart, toward Sagittarius A star itself. But to our eyes, it is only a soft glow, a faint blur behind a veil of darkness. The true brilliance of the galactic center is hidden by distance and dust. Between us and that glowing core lie countless clouds of gas, each one absorbing and scattering visible light. This is why the center of the Milky Way, so bright in infrared and radio waves, appears dim and smoky from Earth. It's as though the galaxy has drawn a curtain between us and its most secret place. Even so, that faint glow carries a strange magnetism. For astronomers and dreamers alike, it is a reminder that something powerful, something eternal, lies beyond our sight. If you could strip away the obscuring dust, the view would be breathtaking. The night sky would blaze with thousands of stars packed so closely together that shadows would barely exist. The galactic bulge would shimmer like molten gold, its stars orbiting the unseen gravity well at its core. Nebulae of ionized gas would glow in red and violet arcs, sculpted by winds from massive stars and the relics of supernovae. And through it all, Sagittarius A star would sit in silence, its influence felt, not seen. Radio telescopes reveal what our eyes cannot. Instruments like the Very Large Array, ALMA, and the Event Horizon Telescope have turned that faint glow into maps of structure and motion. Through them, we see how entire star clusters orbit the black hole, how filaments of gas twist into spirals, how shockwaves ripple outward through the galactic disk. What appears as a smudge in the sky is, in truth, a dynamic, luminous engine. To think that light from the galactic center has been traveling toward us for 26,000 years is humbling. When it began its journey, human civilization did not yet exist. Our ancestors were painting on cave walls and watching the same stars, unaware that they too were orbiting something vast and unseen. The light that reaches our telescopes tonight left the core long before the first pyramids rose, before the first words were written. To observe Sagittarius A star is to look deep into both space and time, to see not what is, but what was. And yet, despite that immense distance, we are connected. Every atom in our bodies, every molecule of air, every photon we see was shaped by the galaxy's gravitational rhythm. The same invisible forces that guide the stars at the center also guide our sun around the galactic disk. One full orbit takes 230 million years, a galactic year. We have only completed 1/5 of one since the dinosaurs walked the Earth. From here, the Milky Way's core seems quiet, distant, almost peaceful. But we now know that beneath that calm glow lies ceaseless motion. Stars colliding, matter falling, magnetic fields twisting, and space-time itself trembling under the weight of 4 million suns. It is the universe in miniature, a reflection of creation and destruction intertwined. So when you gaze towards Sagittarius on a summer night and trace that pale band of starlight, remember that you are looking into the galaxy's beating heart. The light you see is ancient, but the story it tells is alive and ongoing. The galactic center may be far beyond our reach, but in its gravity, we all belong. The photons that reach us from Sagittarius A star began their trip when early humans first learned to shape tools. Every image we take is ancient light, a cosmic time capsule. When we look toward the galactic center, we are not seeing the present, we are seeing the past, carried to us on waves of light that have crossed 26,000 years of space. Every observation, every photograph, every flicker of radio or infrared data is a message from a time long gone. The light we receive tonight left Sagittarius A star when humanity was still discovering fire, carving the first symbols into stone, and beginning to wonder about the stars that burned above. Light is our only messenger across the cosmos, but it moves at a finite speed, 299,792 kilometers per second. To the human mind, that seems infinite, yet across galactic distances, even light takes its time. By the time it reaches our telescopes, civilizations have risen and fallen, continents have shifted, and oceans have changed their shape. Every image of the Milky Way's heart is an echo, a memory preserved in photons that refuse to fade. Those photons travel a perilous road. Along their journey, they are scattered, absorbed, and re-emitted by clouds of dust and gas. Many never make it at all, swallowed by the dense molecular lanes that thread the spiral arms. But some survive, slipping through narrow windows of transparency in the interstellar medium. It is through those gaps, those cosmic keyholes, that we glimpse the center's glow. What we see is not a direct view, but a mosaic of survivors, particles of light that endured a voyage across space and time. Each photon carries a signature, a wavelength that encodes the temperature, motion, and chemistry of its source. When scientists spread that light into spectra, they read it like a diary. The dark lines reveal which elements emitted or absorbed it. The slight shifts in frequency tell how fast the source was moving. In every glimmer, there is a story. The James Webb Space Telescope and Event Horizon Telescope both rely on this ancient light. Webb sees the infrared glow of stars and dust near the black hole, while the EHT uses radio waves to reconstruct its very shadow. Together, they allow us to see across epochs, to turn faint, faraway photons into knowledge. It is as though the galaxy has been sending us postcards for millennia, and only now have we learned how to read them. To look at Sagittarius A star is to touch time itself. The light we see today left the black hole's surroundings when glaciers still covered much of Earth. when mammoths and saber-toothed cats roamed the tundra. The stars whose orbits we now track may have shifted dramatically since then, their paths rewritten by gravitational encounters. Yet in our telescopes, they appear frozen, like ghosts suspended in their ancient dance. And perhaps that is what makes astronomy so profound. It is not the study of space, but of time made visible. Every photon is a survivor, a record of something that once existed and may no longer be. When we collect that light, we are not just observing the universe, we are preserving its memory. So when we gaze at images of Sagittarius A, glowing faintly through the dust, we are not looking at what is. We are looking at what was. We are seeing the heartbeat of the Milky Way as it pulsed 26,000 years ago, a message from the past, still traveling, still radiant, still telling us that across the great darkness, nothing truly disappears. Even at the speed of light, a signal from the galactic center takes 26,000 years to arrive. What we see now is already history, a memory of what once was. It's easy to forget that when we look into the night sky, we are not seeing the universe as it is, we are seeing it as it was. The further we look, the older the light becomes. Every star, every galaxy, every faint glow is a record of a moment long gone. And when we gaze towards Sagittarius A star, we are peering into a memory 26 millennia old. Light that began its journey before the first cities, before language had fully formed, before humanity had learned to measure time. If our thoughts could travel at the speed of light, they would still take 26,000 years to reach the galactic core. By the time a single message from us arrived, civilizations might have vanished, continents drifted, and the stars themselves shifted in their constellations. The universe moves slowly, but its distances turn every signal into an echo from the past. In that sense, astronomy is an act of time travel. Every photon captured by a telescope is a messenger from history, carrying the memory of a place and moment now unreachable. When scientists study the galactic center, they are decoding events that occurred while Earth was still in the midst of its last ice age. The light that reaches us tonight is already ancient. The flares we observe, the patterns we map, the shadows we photograph. And yet, this delay does not distance us, it connects us. For as light travels, it preserves continuity. The photons that began their journey so long ago still obey the same laws of physics, still follow the same constant speed, still carry information across the gulf unchanged. They are, in a way, thoughts of the universe, traveling minds of energy, moving with perfect precision through the void. It makes you wonder what the galaxy would see if it looked back at us. The light leaving Earth right now will not reach Sagittarius A star until the year 28000. What will our planet look like then? Will anyone be here to remember what we once were? To the stars, we are already a message in transit, a faint blue whisper on its way to the center. This delay between seeing and being gives the cosmos a kind of melancholy grace. Every observation is a look into absence, a glimpse of something that has already moved on. But it's also an act of communion, because to see ancient light is to share in its endurance, to touch the persistence of something that traveled for eons to be seen. Even light, as fast as it is, cannot outrun time. The moment it leaves its source, it becomes memory, a record of what once was. And when it finally arrives, across thousands of light years, it meets the mind of the observer, who turns it into meaning. So perhaps the real speed of thought is not measured in kilometers per second, but in understanding, in our ability to take that distant, delayed light and see in it the present, the past, and the vastness that binds them. For in every photon, the universe is thinking, and through us, it remembers. Orbiting satellites like Chandra, Spitzer, and JWST keep their gaze fixed on the core, gathering data that humans turn into meaning, and meaning into wonder. High above Earth's restless atmosphere, these silent machines drift in darkness, their instruments pointed toward the galactic heart. They do not sleep. they do not blink. Each orbits with patient precision, collecting faint whispers of energy from across space and time. Where our eyes see only night, they see structure, heat, motion, and light that has traveled across millennia to reach their mirrors and sensors. The Chandra X-ray Observatory listens to the galaxy's most violent frequencies. It watches as gas near Sagittarius A star flares into sudden brilliance, emitting bursts of X-rays when matter is torn apart at relativistic speeds. Each flash it records is a heartbeat of the black hole, a pulse that reveals how matter behaves on the edge of physical law. Through Chandra's gaze, the invisible becomes luminous, and destruction becomes a form of light. The Spitzer Space Telescope, before it was retired, mapped the galactic center in infrared. Its vision pierced the dust that blinds visible light, revealing the crowded neighborhoods of stars orbiting the black hole. Through its lens, astronomers saw not emptiness, but a city of suns, dense, glowing, and alive with motion. Spitzer's final images of Sagittarius A star are still among the most haunting ever taken. The black hole's surroundings glowing in warm gold and crimson, like embers fading into infinite dark. And now, the James Webb Space Telescope continues that legacy, seeing deeper and finer than ever before. Its golden mirrors gather ancient light in exquisite detail, uncovering patterns within the chaos, threads of dust, clusters of new stars, and the faint shimmer of gas shaped by forces beyond comprehension. Webb does not simply photograph the galactic center. It translates it, turning raw radiation into art, into knowledge, into wonder. Each of these watchers views the same truth from a different wavelength, like musicians playing in harmony across the electromagnetic spectrum. Together, they compose a symphony of the unseen. X-rays from Chandra, infrared from Webb, radio waves from ALMA, sub-millimeter whispers from the Event Horizon Telescope. Each note carries a piece of the story, each frequency revealing another face of the same mystery. Their data streams continuously back to Earth, tiny packets of information, crossing thousands of kilometers, reaching antennas in deserts, on mountains, and deep in orbit. Scientists receive them, decode them, and reconstruct the cosmos one pixel, one frequency, one calculation at a time. What begins as a trickle of electrons becomes an image, a discovery, a realization that reshapes our understanding of reality. And then, beyond science, it becomes something else. Wonder, awe, a quiet knowing that we are seeing not just with our instruments but with our imagination. The satellites may be silent, but their work speaks a language older than words, the language of curiosity, of reaching outward toward the infinite. These orbiting sentinels remind us that humanity is not confined to one world. We have built eyes that never close, that stare across eternity and send their visions home. They show us the heart of our galaxy not as a myth or a metaphor, but as something real, something we can measure, interpret, and feel. In the end, these silent watchers are our proxies in the vastness. They gather the light we cannot see and return it to us transformed. Through them, the universe tells its story, and through us, it learns to listen. If the Milky Way were the size of Earth, Sagittarius A star would be a grain of dust at its center. And yet, every star, planet, and molecule depends on its pull. The scale of our galaxy defies intuition. 100 billion stars, each with its own story, orbiting a single, unseen mass that binds them all together. From our distant perch in the Orion Arm, we drift around the galactic center once every 230 million years, carried by gravity's invisible thread. In that time, continents rise and vanish, species appear and fade, civilizations ignite and dim. And yet, through all of it, the black hole at the center endures, motionless, patient, the axis upon which everything turns. To grasp this scale is to let go of ordinary meaning. Light itself, the fastest thing in existence, would take 26,000 years just to reach Sagittarius A star from where we stand. The galaxy's diameter spans 100,000 light-years, a distance so vast that even imagining it feels like reaching into infinity. Between stars lie oceans of emptiness, where entire solar systems could vanish without trace. And at the heart of it all, smaller than the orbit of Mercury, sits the black hole, 4 million times the mass of the Sun, yet occupying a region barely larger than our solar system. If the Milky Way were scaled down to the size of Earth, our Sun would be smaller than a single grain of sand, and Sagittarius A star would be a mote of dust near its core. And still, that dust would dictate the motion of continents, oceans, and clouds, its gravity defining the structure of the whole. Such is the paradox of the cosmos. The smallest thing can hold the greatest influence. Our minds, evolved for the scale of rivers and mountains, struggle with these magnitudes. We think in seconds, not centuries, in kilometers, not light years. But to the universe, time and distance are fluid, interchangeable, woven together into the same fabric. The galaxy's rotation, the orbits of its stars, the expansion of space itself, all move to a rhythm so vast that even eternity has a tempo. And yet, despite that immensity, we are connected. The iron in our blood, the calcium in our bones, the carbon in our breath, all were forged in stars that orbit the same galactic center. Their ashes became the matter that became us. We are not separate from the Milky Way's structure. We are one small expression of it, tiny ripples in a cosmic sea held together by Sagittarius A star's invisible pull. To understand this is to feel both humbled and uplifted. Humbled because we are infinitesimal compared to the galaxy that contains us. Uplifted because we belong to it completely. We are part of its design, shaped by forces older than life itself. Every heartbeat, every breath, every spark of thought is a local echo of galactic motion, tiny imitations of the same gravity that guides the stars. When you look up at the Milky Way on a clear night, remember that every speck of light is a sun, and every sun is moving in an endless orbit around a single, silent source. The galaxy turns as one vast organism, balanced between chaos and harmony, its arms like waves frozen in mid-motion. And somewhere in that whirl, we drift, a conscious spark in a spiral of light, aware of our own smallness, yet capable of understanding the infinite. That, perhaps, is the greatest scale of all. Not the size of the galaxy, but the vastness of the human mind, able to hold it within a single thought. Our Sun, too, orbits this unseen center, taking 230 million years to complete a single revolution. Every sunrise is part of that vast celestial dance. Though we seldom feel it, our world is in constant motion. The Earth turns, the Moon circles us, and together we orbit the Sun. But beyond that, our entire solar system is moving, swept along by the gravitational current of the Milky Way. We are passengers in a slow, majestic waltz around Sagittarius A star, the galaxy's heart. Each second, our star system races through space at 828,000 kilometers per hour. And yet, from our vantage point, the heavens seem still. One complete orbit around the galactic core, one cosmic year, takes about 230 million Earth years. The last time our planet was in this same position relative to Sagittarius A star, dinosaurs had just begun to roam the Earth. The continents were fused together into the supercontinent Pangaea, and mammals had yet to evolve. Every sunrise since then has been a single step in our journey around the galaxy, a rhythm so slow that even time itself seems to lose meaning against it. If we could view the Milky Way from above, we'd see a grand spiral of stars and gas, with the Sun tracing a delicate arc along one of its arms, the Orion arm, a narrow, luminous ribbon between larger spirals. Our path around the center is not a perfect circle, but a wave, rising and falling gently through the galactic plane like a leaf drifting on a tide. Over millions of years, our system weaves above and below that plane, oscillating through bands of interstellar dust and light. The galaxy's motion is not random, it's harmony on a cosmic scale. Every star, from the smallest red dwarf to the brightest supergiant, moves according to gravity's choreography. Some dance close to the core, whirling at incredible speeds. Others, like our sun, glide farther out, slower but steadier. Together, their collective motion forms the spiral arms themselves, patterns born not from stillness, but from synchronized movement. Even the black hole at the center, though seemingly still, participates. Its immense gravity anchors the dance, giving every orbit its rhythm, every arm its grace. Without Sagittarius A star, the galaxy would lose coherence. Its spiral would fade into chaos. The black hole doesn't dominate the dance, it conducts it. When you look up at the night sky, the stars seem fixed, but they are all moving, each tracing its own orbit in the grand rotation of the Milky Way. The constellations that guide us now will not look the same in a few million years. Orion's belt will drift apart, the Big Dipper will twist and fade, and new constellations will take their place. Yet the music of motion continues, unbroken, timeless. Every sunrise, every heartbeat, every passing century belongs to this dance. The solar system's path through the galaxy shapes everything, from the cosmic rays that strike our atmosphere to the long cycles of life and extinction on Earth. Even our planet's climate may carry traces of this galactic rhythm. We may feel small, orbiting a modest star in an average arm of a single spiral galaxy, but the truth is the opposite. We are not observers standing outside the cosmic dance. We are part of its motion, made of the same dust that spins and falls, guided by the same gravity that binds the stars. And so, when the first light of morning reaches you, remember, it is not just the Earth that turns toward the sun. It is the galaxy itself, spinning slowly through eternity, carrying us along in a dance that began before life existed and will continue long after we are gone. Photons bent near the event horizon can orbit the black hole multiple times before escaping. When we look towards Sagittarius A star, we may be seeing the same light more than once. Light, for all its speed, is not immune to gravity. Around Sagittarius A star, it moves as if caught in a cosmic maze, its straight paths curved by the sheer distortion of space-time. Photons that stray too close do not fall directly in. Some are bent, deflected, or trapped in looping orbits known as the photon sphere, a fragile ring where light circles the black hole endlessly, balanced between freedom and oblivion. A single beam can wrap around the black hole several times before finally escaping, arriving at our telescopes centuries, even millennia, after it first began its journey. This means that when we observe the region near Sagittarius A star, we are not seeing a single instant. We are witnessing echoes, multiple copies of light from the same event, delayed and distorted by gravity's lens. A flare that lasts seconds at its source may appear smeared across time and space, its photons arriving to us in different waves, each one curved by a different path through space-time. In this way, the black hole becomes not just an object, but a mirror of time, reflecting moments back to us long after they have passed. Einstein's theory of general relativity predicted this gravitational lensing, a bending of light so strong that it can make a single star appear in many places at once. Near a black hole, the effect becomes extreme. The surrounding glow we see in images from the Event Horizon Telescope is not light emitted directly toward us, but light that has been bent, wrapped, and folded around the black hole's shadow. What we see is light that has remembered its path, a memory made visible. Imagine a photon skimming the edge of the event horizon. It races at the speed of light, yet its path is anything but straight. Each orbit tightens, each loop shorter than the last, until finally, by chance, it escapes. In those moments, it has seen everything: the twisted geometry of space-time, the warping of time itself. And when it reaches us, thousands of years later, it carries that experience encoded in its frequency, its angle, its faint red-shifted color. The black hole doesn't just trap light, it organizes it. It turns passing photons into messengers, choreographed by curvature, sent outward to tell us how space-time feels at its edge. These photons, though ancient, remain precise, like notes in a song replayed across eons, carrying the melody of relativity itself. In a sense, the light around Sagittarius A star remembers what we cannot. It remembers the motion of gas that once flared and vanished. It remembers the orbits of stars that no longer exist. It remembers the magnetic storms that raged in silence. When we collect that light, we are collecting memory, time folded and sent back to us in the form of brightness and color. Even now, astronomers working with the Event Horizon Telescope are decoding these echoes, teasing apart the tangled paths of photons to reconstruct the black hole's structure. Every image we've seen, every glowing ring, is a composite not just of space, but of time. It's a portrait painted with delayed light, a cosmic palimpsest where the present is layered over the past. So when you look at that golden ring around darkness, remember that it is more than an image. It is a recording. You are seeing the same photons that once circled a black hole, perhaps more than once, before finding their way here. And in that light lies memory, not just of what was seen, but of how space-time itself remembers. For around Sagittarius A star, light is not simply illumination, it is history, endlessly looping, endlessly reborn. Between the chaos and radiation, there is stillness. The core hums like a sleeping beast, waiting centuries between breaths. Despite the flares, the storms, and the relentless motion of matter near Sagittarius A star, there are moments, long, silent intervals, when the galaxy's heart grows calm. The light dims, the plasma subsides, and for years, even centuries, the black hole enters a state of quietude. In these stretches of time, the galactic core feels less like a furnace and more like a deep ocean trench. Dark, immense, and profoundly still. Astronomers have observed that Sagittarius A star is unusually tranquil compared to other supermassive black holes. Many galaxies host active nuclei that blaze across millions of light years, devouring gas and dust in furious outbursts. But ours is different, subdued, restrained, as though it inhales slowly, then holds its breath for millennia before exhaling again. Even at its most active, its radiation is modest, its flares brief, its hunger contained. During these periods of quiet, the energy that once roared outward settles into low whispers, soft X-rays, faint radio murmurs, and the lingering glow of old flares fading into the void. Around it, the dense star fields continue their orbits, oblivious to the silence at the center. The magnetic fields, still coiled and tense, shimmer faintly, like threads of light strung through fog. It is a cosmic lull between acts, a pause in a play billions of years long. Scientists think this stillness is temporary, a consequence of the black hole's diet. When no fresh gas or dust drifts close enough to be consumed, Sagittarius A star becomes dormant, but the galaxy's core is never empty. Massive molecular clouds wander the region, drifting like cosmic weather. One day, one of these clouds will pass too near, triggering another feeding event, a brilliant flare, a new wave of energy, another breath of fire from the heart of the Milky Way. To imagine this silence is to imagine time slowed beyond measure. In human years, these quiet spans are longer than recorded history. Entire civilizations could rise and vanish while the black hole slumbers. And yet, this calm is not emptiness, it is tension, potential, waiting to ignite. The universe is patient in ways we can barely comprehend. If you could stand near the galactic center during this stillness, the view would be haunting. The space around you would glow faintly with diffuse starlight. Clouds of dust would drift like smoke, illuminated by distant suns. No sound, no motion, only the slow, imperceptible drift of orbits measured in millennia. The black hole would not announce itself. It would simply be a silence so perfect that it bends even thought into awe. In that silence lies something sacred. The same gravity that can shred stars can also cradle serenity. The same space that births radiation can host infinite calm. It is the universe's reminder that chaos and peace are not opposites, but phases of the same rhythm, a cosmic inhale an exhale that has continued since time began. The quiet between stars is not the absence of life, it is the breath that sustains it. Between each flare and collapse, between every pulse of energy and silence, the galaxy rests. And in that rest, the pattern of everything is renewed. Even black holes, it seems, must sleep. To study Sagittarius A star is to confront ourselves. The same laws that govern its fury govern the neurons firing in our brains. We are, in a way, the universe observing its own heart. Every photon that reaches our telescopes, every equation written to describe the curvature of space-time, is not just a study of the cosmos, it's a reflection of what we are made of. The atoms composing our hands, our instruments, and our thoughts were forged in stars that orbit this same galactic center. The gravity that binds Sagittarius A star also binds the molecules in our cells. The same mathematics that predicts the orbit of a star near the black hole also describes the electric field sparking across the synapses of the human mind. When we observe the galaxy's heart, we are not standing outside of it. We are participants, made from the same material, shaped by the same forces. We are fragments of the universe that have become self-aware, turning back to look upon the whole. The light we collect from Sagittarius A star does not merely travel across distance, it travels across connection. It reaches us because we, too, are part of the network it anchors, a spiral of matter, motion, and memory. This is the quiet revelation of cosmology, that the universe does not create observers separate from itself, it creates observers within itself. Through us, it perceives. Through our instruments, it measures. Through our questions, it understands. Every calculation about the black hole's spin or mass is, in a profound sense, the cosmos describing its own anatomy. Sagittarius A star is not foreign, it is family. The event horizon, the accretion disk, the light that bends and folds, all of it follows the same physical principles that govern the smallest events inside us. Quantum mechanics describes both the orbit of electrons and the evaporation of black holes. Thermodynamics governs the burning of stars and the metabolism of life. The same entropy that drives galaxies toward equilibrium drives the slow fading of memories and moments. The difference is not in kind, but in scale. It is humbling to realize that our ability to wonder about Sagittarius A star is itself a product of its existence. The atoms that formed our brains were once trapped in the gravity of other stars, and those stars orbited the same galactic center we now study. Over billions of years, that matter collapsed, fused, and scattered until, somehow, it began asking questions about itself. In a literal sense, we are the Milky Way thinking about the Milky Way. And perhaps that is the greatest beauty of all. The universe, in its vastness, does not need to know itself, but it does. Through beings who build telescopes, who listen to the faint whispers of radiation, who write equations and imagine the unseeable, the cosmos achieves self-reflection. We are its mirror, and when we gaze towards Sagittarius A star, we are not just observing a black hole, we are witnessing consciousness itself reaching back across space and time to see its own origin. In the golden light that curves around that shadow, in the delicate flares and the quiet orbits of stars, the universe shows us both its mystery and its familiarity. We look outward and find ourselves looking inward. The abyss is not just something we observe, it's something we come from, and something that still lives within us. Sagittarius A star is more than a black hole. It is a question, a reflection, a reminder that existence itself is circular, that what falls will rise in another form, that what wonders will, in turn, be wondered about, and that somewhere, deep within the silence of space-time, the universe is still looking back and seeing itself in our eyes. Perhaps the greatest lesson of Sagittarius A star is that creation and destruction are not opposites. They are the same process, viewed from different sides of time. The black hole at the heart of our galaxy is often described as a monster, a devourer of light, a cosmic abyss from which nothing escapes. And yet, the more we learn about it, the more we realize that its darkness is not absence but balance. What it consumes, it redistributes. What it erases, it transforms. The collapse of matter into gravity's grasp is not an ending, but a continuation, a reorganization of the universe's energy into new forms, new rhythms, new beginnings. When we study Sagittarius A star, we see that destruction is never final. Every flare of radiation it releases, every particle it casts back into the galaxy, becomes the foundation for new creation. The same jets that burst from its magnetic poles carry the materials that form future stars. The energy that once burned in one place becomes the fuel for light somewhere else. Even in its silence, the black hole shapes the destiny of billions of suns, guiding their orbits, defining the galaxy's form, and maintaining the harmony of its spiral. Darkness, then, is not the enemy of light, it is its teacher. Without shadow, brightness has no meaning. Without loss, creation has no urgency. The void around Sagittarius A star reminds us that absence is as essential to the universe as presence. Every star that dies feeds the next. Every collapse releases new energy. Every silence contains the seed of another song. The black hole's lesson is one of perspective. To stand at a distance, it appears final, even fatal, a boundary from which no light returns. But if we shift our understanding, if we see through the eyes of physics and time, we find continuity instead of closure. Entropy becomes renewal. Gravity becomes creation. The universe is not wasting energy. It is circulating it, forever reworking its materials into new patterns of being. Even our own existence depends on this cycle. The atoms in our bodies once belonged to stars that were torn apart by forces not unlike those near Sagittarius A star. Their deaths scattered the heavy elements that made life possible: carbon, oxygen, iron, calcium. Each forged in fire and released through destruction. We are, quite literally, born from what the universe chose not to keep. So, when we look into the black hole's shadow, we are not staring into oblivion. We are looking into the mechanism of renewal, the deep structure that makes creation possible. It is the same truth that governs everything from galaxies to cells, that endings and beginnings are never separate, only sequential. Sagittarius A star does not just teach us about the cosmos, it teaches us about ourselves. That growth comes from surrender, that change requires loss, that the most profound transformations begin in darkness. And perhaps that's the final paradox, that the darkest place in the galaxy is also its source of order, that the stillest point in space-time is where motion begins, and that in understanding what we cannot see, we discover why anything can exist at all. In the glow surrounding that perfect shadow, the universe reminds us, light is not the opposite of darkness. It is born from it. At the center of everything, we found silence, not emptiness, but balance. A place where gravity becomes peace, and light, even as it falls, seems to rest. We came seeking answers in the dark and found reflection instead. That the same forces shaping stars also shape us. Sagittarius A star reminded us that endings and beginnings are the same motion seen from different sides. That even in the deepest night, the universe is still creating, still breathing, still beautiful. As you drift towards sleep, let that thought stay with you. You are part of the same vast rhythm, the heartbeat of a galaxy, the whisper of light that never truly fades. Rest now. The stars are still listening,